Hello everyone. How's everyone doing? We're gonna continue with Dart today. Probably a little bit shorter than usual. But yeah, I'll just get going. So last time I recall that we finished basically our control flow. And we kind of skimmed over functions, we looked at libraries and imports, and then we got lost in all the existing libraries. So I figured maybe today we're gonna properly go through functions because it's not a subject that we should skip. So we're gonna do that. Then we're gonna start with classes and objects. What I thought is that maybe we'll kind of start making a little Dart project in the meantime as we get past functions and start with classes, just to start exercising what we're learning and start building up a little maybe backend project. Then yeah, we'll try that. Why not? So yeah, functions. Let's learn about those. So Dart is a true object-oriented language. So even functions are objects and have a type, function. This means that functions can be assigned to variables or passed as arguments to other functions. You can also call an instance of a Dart class as if it were a function. For details, see the callable objects. Yeah, we saw the callable objects that we kind of can define a call, and hey, you can call objects for some reason. I'm sure it's useful in some kind of patterns, especially probably for when you're making your own libraries for a good API. So here's an example of implementing a function. So we have function is noble that returns a boolean. It takes one argument, that's an integer, atomic number, and then we've got the body, which is, calls a, private? A private function, a private, probably some kind of private variable that holds a bunch of stuff, and we return it, right? If it's not null. Okay, so if it is in the list, we return true. If it's not on the list, we say false. So we're basically check if it's a noble gas. Although effective Dart recommends type annotations for public APIs, the function still works if you omit the types. Okay, that's good to know. I mean, yeah, we shouldn't do that because function is like a function is a definition of some kind of API, and if you don't specify the results, you start getting problems with maybe your code starts to compile slowly. As a user of that function, suddenly you cannot rely that, it's always going to return this thing because, it doesn't specify that. It might change at any point. So yeah, definitely go returning, specifying the return value. It will also make writing a function easier because you will actually get some kind of help with errors within the function. If you have the return type specified, you'll actually know that, I'm always returning what I'm supposed to. So for functions that contain just one expression, you can use a shorthand syntax. So this also looks the same. Okay, so we basically have an arrow function and what we're returning. Okay, so this sounds like we can't just, put square brackets here and make it into that. So that's interesting. So the arrow function, the arrow expression syntax is a shorthand for this. Okay, explicitly. So the arrow notation is sometimes referred to as arrow syntax. There we go. Only expressions can appear between the arrow and the semicolon. Expressions evaluate to values. This means that you can't write a statement where Dart expects a value. For example, you could use a conditional expression, but not an if statement. In the previous example, noble gases, atomic number, whatever, returns a Boolean value. The function then returns a Boolean value that indicates whether atomic number falls into the noble gas range. Okay, I mean, that's cool. It's simple. This way we don't deal with those extra brackets and extra return. We just, standard practice. Standard for JavaScript, standard for C#, and probably many other languages. All right, let's go to parameters. A function can have any number of required positional parameters. These can be followed either by named parameters or by optional positional parameters, but not both. Okay, so yeah, basically now I recall that we have this weird concept with both positional and named parameters. So yeah, let's see it more in practice in context of functions, because we were learning the most about them when in the context of records. You can use trailing commas when you pass arguments to a function or when you define function parameters. Okay, so name parameters. Named parameters are optional unless they're explicitly marked as required. When defining a function, use all those curly brackets, param1, param2, to specify name parameters. If you don't provide a default value or mark a named parameter as required, their types must be nullable, as their default value will be null. Okay, so we won't get like a 0 value assigned by default, nothing of that sort. It will be always null. Okay, makes sense. So we have enable flags, right? It returns nothing, but what it takes is, because we have those curly brackets, so these are name parameters. Bold, it's a nullable Boolean, so it will be null. Hidden, which is again nullable Boolean, so but default will be null. We didn't assign any values to them. When calling a function, you can specify named arguments using param name value. For example, this. So we don't have to use curly brackets here anymore. We just say, hey, bold is true while hidden is false. To define a default value for named parameters besides null, use equals to specify a default value. The specified value must be a compiled time constant. For example, okay, so here we just define, hey, this is that, this equals false, and these will be the default values. This way we don't have to make them nullable, because we are guaranteeing that they always have an actual value. All right, that's simple. Now when I think about it, in C#, everything is the same in JavaScript. Everything is kind of positional. We give them the names, but they don't really matter. But in C#, you can just call them by names. And anyway, this way you can reshuffle their order. So here we can kind of have both, and they're separate. Interesting. So those name ones, basically, they always are optional. Interesting. And bold will be true, hidden will be false. Exactly, because if we specify just one, that's it. Alrighty. If you instead want a name parameter to be mandatory, requiring callers to provide a value for the parameter, annotate them with required. Okay, so we can just mark them as required, and we're basically forcing everyone to, you need to specify this thing. All right, if someone tries to create a scroll bar without specifying child argument, then the analyzer reports an issue, right? Parameter marked as required can still be nullable. Okay, so even though we marked this as nullable, it won't receive a default value at all. We'll just get an error if we're gonna call it without it. Alrighty. So you might want to place positional arguments first, but Dart doesn't require it. Dart allows named arguments to be placed anywhere in the argument list when it suits your API. Okay, I mean that makes sense because they're not being called in a positional way. You always have to call them explicitly, right? So repeat times 2, and then, I know, provide an extra function here, right? Okay, that makes sense. So optional positional parameters. Wrapping a set of function parameters in, in square brackets marks them as optional positional parameters. Oh, okay. That's how we do it. It's a little bit like as if we were doing stuff in the terminal, right? Defining like, oh, this is an optional. Or in documentation, it's often marked as optional. So if you don't provide a default value, their types must be nullable, as their default value will be null. Yep. So let's see. So we define function say. It takes from, this is positional. Notice that we don't have it in curly brackets. So this is positional. The name doesn't matter to the color of the function. So we have from that needs to be a string, message that needs to be a string, and this one is wrapped in square brackets. So that's still positional, just optional. And the whole idea is that those optional parameters, they need to be optional positional parameters. They need to be at the end after all those. Yeah. And I understand that we can mix those optional positional with named. So yeah, that doesn't matter, right? We just have that, and this that by default will be null. Here's an example of calling this function without the optional parameter. Yeah, we just did Bob, howdy. So we provided those two. We didn't specify a device, so that device is not null. We'll just say, add there with a device. So by default, there will be none. Yep, Bob says howdy. And here's an example of calling this function with a third parameter. Yep, we just add a third one, and there you go. We got with a smoke signal. To define a default value for an optional positional parameter, besides null, use equals to specify default value. So it's basically the same thing. The specified value must be a compile time constant. So just like before, we have device, and by default will be carrier pigeon. Okay. Bob says howdy with a carrier pigeon. There you go. Even though we didn't specify the device, we've got a default value. All right, so that's simple. I just want to go back to the beginning and understand parameters. These can be, so a function must have any number of required positional parameters, right? Any number, it could be 0. We don't have to have any positional ones, but they are, they're the first one to define, right? And these can, but don't have to, be followed either by named parameters or by optional positional parameters, but not both. Okay, so we basically can't have optional named and named parameters and optional positional parameters. That's too bad. I mean, it sounds like it could be implementable, but I wonder if this would be. Do we have function overloading? I think we have function overloading in Dart, right? So having but named are always explicitly named. You can't just call them like positional. Oh, next. You have to name them anyway. So what's the big deal? Why not both? Is it like so unreadable at that point? I'm not sure, but that's kind of a bummer, right? What if you want to have like a configuration function where you need to pass like 2 arguments, 2 whatever they call them parameters, 2 parameters, and let me quickly turn on some kind of IDE. I believe I had a proper folder for Dart, I think. No. I'm just looking quickly off screen because I thought I had something ready for Dart. Let me just create a new location then. Let's go here. We're gonna do make directory and temp/learning dart. Okay, we're gonna go here and run VS Code, and that should be good enough, right? Let's just put it in a second screen. Yes, I trust. Make it a little bit larger for stream, like super large. And let's just create a functions dart. Great. So let's say that I want to define a function, right? Something similar to the one of positional ones. So these are optional, right? So let's say that we want something like this. Where we have the say function. Does something like full screen work here? Not much. Oh well. So, we have, I don't know, configure. Something like that. We want to have some function to configure something. Maybe, will be, first of all, will be string IP address, right? And the second parameter we always have to give is maybe, I don't know, path. But then optionally, we want to provide that, you know what, as an option, you can also provide something like a port. And we'll give it the, normally we port 8080. I mean, normal, right? And we'll just do return. Yeah, we don't care about implementation right now. So therefore, I will be able to just call it, hey, configure IP address will be, I don't know, whatever. This is the IP address, right? A path will be, I don't know, API. And that's it, right? Nothing crazy here. So, whoops. What was the final whatever config is this. So we don't have any errors. So this way we can decide we don't provide any port, or we I don't know, decided to deploy it on port 80. But it's often, especially in JavaScript, that you kind of want to add this optional with default value kind of config, where we can specify additional values. So, normally it will be like maybe, I know, object, something like extra config, right? Or maybe just literally config within that config. And by default, it's just empty or something. How on earth was I supposed to create a new object here? I don't think we needed a new. Whatever. Nullable, right? And this way we could, after that, only after the port, we could specify it. That, hey, this is our config, something here, right? But that means that we cannot skip it here. We would need to put some default value here. We can just skip it because it's position 1. So it would be nice to say, hey, I want to do config is this. Therefore, it would be so nice if I could say, you know what, just in case, if you want, you can specify this name parameter, and therefore you can throw it wherever you want, even though you don't specify the port. But no, we can't. Why? So this is upset. Okay, so after that, it just expects the closing. I mean, that would make the API so nice because we always have to specify that, but at least we can do that. This way, if we can't do that, we need to put this inside of the config and we're forced to do weird stuff. I'm surprised that they don't give that option. I'm genuinely surprised. And Yusuf, hi, how are you doing? Okay, so at least we know that we have the limitation here and we can't go crazy with how we define our functions. I'm sure there's a reason for that, I just don't know why. Because so far the language seems to be like trying to promote expressiveness. Don't know. Okay, the main function. Every app must have a top-level main function, which serves as the entry point to the app. The main function returns a void and has an optional list string parameter for argument. Okay, so it always needs to return void. We can return like a integer as a result, like a status. Interesting. Here's a simple main function. So void main, and there's our hello world, right? Nothing crazy. Here's an example of the main function for a command line app that takes arguments. So yeah, we just take our list of arguments, nothing crazy here, and we just go over them, right? Whatever the number of arguments is, we can pass them. We can parse our integers and whatnot. Great. You can use the args library to define and parse command line arguments. Okay, so I guess there's some arguments library to make our lives a little bit easier, and that's probably like a default built-in one, right? Yeah, by Dart dev, there you go. And so we have arg parser that we can just do add options, add flags, and does it allow us to like build help stuff and whatnot? No, it's defining commands, dispatching commands, subcommands and whatnot. Okay, so it has some, a way to handle like classic way the commands are done. Okay, displaying usage. There you go. You can automatically generate nice help text suitable for use as the output of help. There you go. So it has all those basic features. That's nice. I like that. I very much like that. Great. It's always nice when libraries of that sort, like somewhat extensive to do this common task, are actually within the standard library. If this is considered a standard library, it's just official. Okay, so functions as first-class objects. You can pass a function as a parameter to another function. For example, we have our print element, and some kind of integer element is gonna print the integer, right? Nothing crazy. And then we've got our list, and pass print element as a parameter. So we go list for each element. Okay, so if we're gonna do print element, hey Taras, how are you doing? Glad you're joining. So yeah, in this case, because print element takes that integer, it will just throw it in here and we'll be calling that instead of us defining separate little function here, anonymous function. Okay, that makes sense, right? We can do that. You can also assign a function to a variable, such as loudify. And we just create anonymous function here, right? That wraps text with extra exclamation marks. And we can, we just assign that loudify just holds the function, right? So we can kind of call it here as if that was a function. But the nice thing is that, maybe you have a statement or whatnot, you just are going to save to the variable whatever function you will be using, instead of, either having two definitions or throwing if statement in here. Tess says, stopping by before falling asleep. Oh, I'm sure my voice will either help you sleep or give you nightmares. Okay, so this example uses an anonymous function. More about those in the next section. Alrighty. So function types. I mean, that's like standard, right? Function types. You can specify the type of a function, which is known as a function type. A function type is obtained from a function declaration header by replacing the function name by the keyword function. Moreover, you are allowed to omit the names of positional parameters, but the names of named parameters can't be omitted. For example, okay, so let's see. Oh, I see. So we have our greet function, right? That either has a some name, some name parameters here, right? And that just prints it. Great. And store greet in a variable and call it. Oh, so okay, function types, that's what they mean. Not the types of different functions. It's just a type that defines function in a type safe way. Ugh. So we basically create a variable, right? And that variable has a type. Like it's a function that will return a void. The first positional parameter will be a string, and it will have a name parameter greeting. And we say that, okay, we're going to assign this function to this thing. Okay, that's great. This way, if we're going to put something like that, our IDE might suggest like, oh, you can use this or that function, and it will guard us from assigning something wrong to it. So, yep, sure, that's standard. I can see using that a lot within actual function definitions, because you could throw in that as, hey, this is a type of maybe this first name argument, right? And this way you're forcing your function that, hey, I'm taking this as a specific argument. Alrighty. So in Dart, functions are first-class objects, meaning they can be assigned to variables, passed as arguments, and returned from other functions. You can use typedef declaration to explicitly name function types, which can be useful for clarity and reusability. Yep, that's awesome. Typedefs, and we can just say, hey, we're gonna call this type something like that. This is the one feature that I'm really missing from C#, that we can't just make those that can be used throughout the project. All right, so anonymous functions. Though you name most functions, such as main or print element, you can also create functions without names. These functions are called anonymous functions, lambdas, or closures. Yeah, so many names for the same thing. An anonymous function resembles a named function as it has 0 or more parameters, is comma separated, and optional type annotations between parentheses. So the following code blocks contains the function's body. So there we go. This is the function, right? We have in first parentheses, we have our parameters. And I guess they use the same notation like, hey, these are all optional, okay? You don't have to specify parameters because maybe that function doesn't take an argument or whatever parameters. Then we have our parameter, right? Or more of them. And each parameter can specify the type, but doesn't have to. So there's lots of optionality here. And of course, then you have the code block. That's great. And something tells me that we can do the same arrow syntax here to make things work. So let's try that. Let's actually try to make this project run or something. Let's say that we have void main, right? We don't need to take any arguments. So this will be our main function, right? Print go away, right? And let's see if we can run it. There we go. It said go away, exited. That's great. So it works. So in theory, we could just say that we have our final sum function, and here we can use that anonymous thing, right? So let's say we'll have literally nothing as an entry, And what it's gonna do is, it's gonna print GTFO. Okay. And of course we close it because it's just that. And then we're just gonna call it. Hey, call this thing because it's that function. And therefore, even though it's like totally unnecessary, we should get where'd it go? Run. Doesn't show us. Dart run functions. There we go. GTFO. Beautiful. Yeah, so that's that, right? That's simple. But because we don't return anything. So maybe we'll just going to return the text, right? And it will be print and whatever it is. We know that this is gonna return a string, but can we define? Because they don't show as if we're defining what the return type is. I don't know if we're gonna get to that at some point, but I would expect that I can define that, hey, this is gonna return a string. No. Function expressions can't be named. String? I'm just trying different syntaxes. No. Interesting. Maybe it's not possible to specifically define what this is supposed to return. Interesting. But for now, it returns a string, so it just instead of some flag, we'll get text to print, right? So we're gonna save it and run it, and we've got the same thing. Let's just add some exclamation marks to make sure that it runs. Yeah, it runs. So because it returns, in theory, I could just do this, right? What could we say? Get lost. And there we go. It works. Okay, so great. We can do that. Beautiful. Yeah. Okay. Makes sense. So that worked. And of course, we can just do additional things, right? Maybe we want to put in a wrapper, right? And what we're going to return is, wait, I can do wrapper like this. And space and another wrapper. Whoa. So therefore, because it's positional, doesn't have any default value. Maybe I'll just say it's something like this. Can I add a default value? Wow, I'm really pushing it. And no, because it's positional, therefore it has to be specified. It doesn't have, oh, I could probably make it like this, and now it's optional with a value of this. And this should probably print with those question marks. Okay, that worked. So we can make it optional. If we don't make it optional, then of course it's not that. But can we make it like this? Name parameter. It should still print it with exclamation mark this time. Okay, that works. But I can do wrapper is, I don't know, bunch of those. Yep, there we go. So, okay, I like it. And we can just make it totally not optional. And suddenly we have to specify it. There we go. Okay, that works. So we have pretty much the same syntax as within normal functions. Okay, that's good. So 0 or more parameters, they need to be comma separated, yep, and optional type annotations between parentheses. And we know that we can use both optional positional and name parameters. Great. The following example defines an anonymous function with an untyped parameter, item. Oh yeah, and we could also specify, hey, because right now we can just give it 1 to 3, and it's going to be happy, because I guess this will be good enough, right? Dart will figure out that it can print that, yeah. But we can say, hey, this is supposed to be a string only, and now it's upset, so we can give it a string. And it will still work. Beautiful. So the anonymous function, with an untyped parameter item. The anonymous function passes it to the map function. The map function invoked for each item in the list converts each string to uppercase. Then the anonymous function passed to for each prints each converted string with its length. Okay, let's see. So we have a list of some fruit. Then we've got, okay, uppercase list. So we basically do our map, and instead of having ready-made thing, we just say, hey, this will take an item and call to uppercase on it. And that's it. Okay, that makes sense. Sure. And then we convert it to a list. Great. Great. So we've got a list of those, and then we basically do for each item. We just print it. Okay, and that's it. That's our only anonymous function here. Okay, that's simple. We could do it with an arrow, right? Because we could easily just do, hey, instead of doing this, well, let's just throw it in main so it doesn't complain. Let's do testing below. Okay. So we basically could change that and make this, right? And we already have it shorter. I would probably personally even format it in this fun way so we know kind of what's happening one after another, like, you know, in a little bit more functional way. But to uppercase. So this is being called on a string. That means I can't just do this, right? Too bad. I guess this is not a NIM language, so it would work in NIM, but not here. Okay, no big deal. Wasn't this for like the double dot or something? Probably. But this is mapping. Oh, okay, we can live with that. This is not like a big deal. I'm already trying to find ways like, oh, can we super optimize that? Make it super short, which is maybe not the point here. Okay, click run to execute the code. Yay, great. We're gonna get output. Yeah. Nothing crazy. So let's move forward. We're halfway through functions. Okay. If the function contains only a single expression or return statement, you can shorten it using arrow notation. Okay, so we don't have to have return statement. Okay. Paste the following line into Dartpad and click run to verify that it's functionally equivalent. So we have the uppercase list is list map. Yeah, we already looked at that. Yep, no big deal. Oh, and look at that, uppercase list for each, and then we take the item and we just print it. So this, I believe, doesn't return any values. We can do that, no big deal. It just won't be returning anything. Okay, so in theory, in here, I could just have it print. Ooh, what did I just do? Print this thing, right? It doesn't return any values, so I can just do, hey, do this and whatever. My print. There you go. It'll still work. As the question marks just in case to see, and there you go, it works. Okay, so lexical scope. Dart determines the scope of variables based on the layout of its code. A programming language with this feature is termed a lexically scoped language. You can follow the curly braces outwards to see if a variable is in scope. So, example, a series of nested functions with variables at each scope level. So we've got top level is true, and then we've got our main, so we have our inside main, right? So here we should be able to access the top level and main level. Inside main. Within function addition, we can do inside function, inside nested functions, so we should be able to access all of those from within here, right? The nested function method can use variables from every level all the way up to the top level. Yep. Lexical closures. A function object that can access variables in its local scope when the function sits outside that scope is called a closure. Yep. Functions can close over variables defined in surrounding scopes. In the following example, make adder captures the variable add by. Wherever the return function goes, it remembers add by. Okay, so this returns a function that adds add by to the function's argument. So there we go. We have function make adder. And our main create function that adds 2. So we do, hey, make adder with 2, remembers it, bam, and we can just call them. Oh, yeah, because it creates the function here, right? Creates an anonymous function that captures, as I would say, this value, even though this, is being used within this little tiny scope, this outer scope, but yet we can still use it. And therefore, when we call it, hey, make adder 2, it returns us a new function that we hold here, and then here another function that hold here, and within that function, it remembers that, oh, I was created with add by that was 2, and I was created with add by that was number 4. And therefore, when we call them, they will add 3 to them accordingly. Great. So I guess the value, I wonder, I don't remember now, but wasn't everything trying to act as a value? Oh wow, I'm mixing languages now, mixing them up, I believe. Because I recall there was some situation where things is being copied, not by reference or whatever. Let's try to do something with a list. Why not? So let's say that I have a list of stuff, right? Whatever, character codes. Great, good enough. Let's call it numbers. And let's say that I have a function that will be something like, hey, get number appender, right? This should give us, this should be a function that returns us a little function that will append something to it, right? So get number appender that takes whatever. It doesn't take any arguments, okay? It doesn't have to. What it's gonna return is a new function that will take, a number to add to the list, and then basically take the numbers. Do we have add? Yeah, add, and it will be the number. Okay, so look at that. We did the double arrow function. So maybe to make it a little bit more readable at this stage of learning, we're just gonna do this, return this thing, okay? So we know that this is a function that will simply do that. And notice that we are capturing the numbers within here, this outer scope. So I'm understanding that a list is just a pointer to entire list. We're not passing it by value. Therefore, if I'm going to be calling it here, maybe some other place, when we define something like print numbers, or like get number printer, okay, it'll be similar. It will return a function that doesn't take anything, but simply prints all the numbers. So it'll be print numbers. Okay, that's all it does. But again, it should capture stuff. So my experiment here would be that, hey, how about first we're gonna do, final printer, right? Will be get number printer. And this way, this suddenly holds the function that has the numbers captured. Then we're gonna do literally execute it, right? So it's gonna print the numbers, our initial value. After that, we're gonna get the appender, get number appender. That's it. And we can call it maybe because we just captured some value. It should be still the initial one. So maybe let's just do 1, 2, 3. Well, that will be our initial value. So then we can call our appender. We're gonna append number 4, okay? And we're gonna call it again with number 5. So in theory, what I think is going to happen, we're gonna at this point end up with 1, 2, 3, 4, 5. But I just want to make sure that this doesn't just hold a copy. So we're gonna do again printer, right? So we're calling this thing, the same function that we created initially, that in theory captured the initial value of numbers. So we need to know if it's gonna print 1, 2, 3, or if it's gonna print everything. And just in case, we're gonna print the actual value of numbers in here. So let's just do that. Let's see what happens when we're gonna call it. Okay, so it didn't capture entire list. It probably printed the first time, right? So properly printed it here. There you go, the initial value. It appended 3 and then 4. So that's why we have them added both. So it's not like this appended to 1, 2, 3. This appended to the result of this. And then when we printed again the actual state of numbers, because it's not a copy, it's just a link to this thing. So we don't have a value, we have a reference. Okay. That follows my intuition, because I feel like I forgot something, because there was something different. Oh, I think everything was by reference. Maybe that was the thing. Like everything is an object, therefore everything is a reference. There's no concept of the value object. Therefore, we can even reference numbers. So what happens if we'll just call it, instead of having a list of numbers, we'll just do the number, right? And that will be, I know, 1. Okay, this will be our number. So get number, instead of appender, we're gonna call it get number changer to what we want to change it, right? And we'll do the number is number. I mean, in theory, it should always just change it, so that should be fine, right? But what if we're gonna do not just return? So print changing the number from the number. Okay, what the hell? There we go. So first we're gonna print it, and this in theory should capture the value, right? Whatever it was there, or maybe not. That's a question. Will it remember some different value, and then can we reassign it? And get number printer will just say, let's say something like, I remember the number to be the number. Okay, so this again should just print it. It should kind of capture it. So we'll get the printer and we do that. And we'll also print the actual value is. And we'll just print it here, right? No big deal. Sorry about those gigantic tooltips, but that's the zoom level fighting us. I can just decrease it a little bit. I hope it's still visible on the stream. And here, instead of appender, we're just gonna do changer, right? So we try to change it to maybe, I don't know, 14. This will be 23, right? Something of that sort. And it will say that it tries to do this, right? And we'll just copy that the actual value is this. We'll try to change it again, this, and we'll try to print it again. So let's see what is the result of this. Okay. So I remember the value to be 1 and actual is. Changing number from 1 to 14, right? And the actual value is this. Why do we have this again? Actual value, what? Printer, do this. The actual value is this. This just changes the value, right? Why do we have the actual value is 14 and then, oh, they went out of order. Okay. That's weird. We had some asynchronous stuff going on. They swapped. But okay, so it doesn't capture it. It literally just holds it as a reference at this point. So I guess what is happening is in this example here, when we create like make adder with 2, because we just created a number, we created a reference to literal number 2. Okay, this is not a variable, nothing else. Therefore, we just create a reference to number 2. Therefore, it holds it, nothing changed it. So that's how it captured it. If we were to change this code where we store that value somewhere and call with it, what will happen then? So let's modify this example. Let's say that the get number changer, we need to provide it a current number, right? What is the current value? And we'll say whenever it prints, it changes from the current number to whatever it was supposed to, right? Oh, and this shouldn't be here. Look at that. Before we do that, let me fix the error that I made because looks like I missed something. There we go. That's why we had things out of order. There we go. We need to return this function and the print needs to be within this function. Come on. Let's run it again because this was something weird. Okay, it still works the same way. It's just now we know for sure. So we'll do integer current number. We need to pass it, and within that function, it should capture it. So what is happening is that if we're gonna do integer get number changer, when we're calling it, right, we're gonna give it the value of maybe, I know, 10, right? It should remember in both cases, hey, I'm changing it from 10 to this. I'm changing it from 10 to this because we hard code it. It has a link just to a number 10 that's not touched anywhere. So we have, I remember number to be 1, actual value is 1, and then from 10 to 14, from 10 to 23, right? Because that reference to the current number just points to the number 10. But what if we are going to create it once the changer is pointing to the number? As far as I understand, this won't capture its actual value as a new thing. It will actually be a reference to that integer. So when we run it, no, look at that. This time it actually captured it. Okay. Because changing the number from 1 to 14, and then again from 1 to 23. Okay. So I guess this is only because we're passing it as an argument, and therefore the argument receives the reference to the actual value, which is the actual number that it's holding, which is 1. Therefore, when it changes, we don't update this particular number because this doesn't point to the variable, the number. This points to the value. We just extracted the value, right? Because this says, hey, extract the value. And this one here, you know, it always references, you know, the value, right? It doesn't capture it here. It will always call it. So we'll look up the value of the current value of the variable rather than whatever we captured. Okay, it makes sense for me. I'm just verifying things. I mean, for me, it's intuitive. Now I'm trying to overthink it. It's weird, but it makes sense. So, sure. At least we don't have a situation where, you know, we copy values or something. Okay, let's move on to tariffs. When you refer to a function, method, or name constructor without parentheses, Dart creates a tariff. This is a closure that takes the same parameters as the function and invokes the underlying function when you call it. If your code needs a closure that invokes a named function with the same parameters as the closure accepts, don't wrap the colon in a lambda, just use a tariff, right? So string buffer, right? And we have the char codes. So we can say, hey, for each of the char codes, just print it. Because print takes one argument, which is something, anything. Therefore, we don't have to do like, hey, for each code and then print the code, right? We can just, hey, if this takes this and this also takes the same thing, why bother? Just do this. Great. So that's a function, tariff. And method is, on something like a buffer, right? A buffer has a function write. So we can do for each write that takes a single character, and therefore it will write it, right? So otherwise it will be for each code, bam, and we need to pass it here. No need to. Okay, that's simple, intuitive, great. Still doesn't get us to the unified function calling like Nim implemented. Wonder what other languages implement that as well, but oh well, we can't have all the nice toys. Although that's like the best toy from Nim in my opinion. Okay, testing functions for equality. Here's an example of testing top-level functions, static methods, and instance methods for equality. So, okay, so we can compare functions, right? We have some kind of foo, a top-level function. We have class A, which has static void baz and just void baz, right? But notice that they all return a void and take nothing as arguments, right? They are doing literally nothing as well. They just don't do anything. So in theory, they're all the same, but this one is just a top level. This is a static method. This one's an instance method, right? And then we've got void main, and we have function x. So this is just, again, definition that there's a function. And by default, that function, I guess, means that, hey, no return type, and no arguments. So it's literally the same kind of shape as all those. So comparing top level functions. So that function is foo. And compare that foo actual thing is this. So that could work, right? Because we're, in theory, comparing the same thing to the same thing. Comparing static methods. I guess that works the same, right? Comparing instance methods. Instance number 1 of A. So we have our first instance and we're taking a function from there. Wait, we have those instances, right? A. Y is W. Huh. X is W baz. Great. So what's the point of this? I am confused. These closures refer to the same instance, number 2, right? So they're equal. So Y baz is the same as X, right? Because Y, right? And X is the same thing. I guess they just want to overcomplicate it for some reason, like with extra transition, like, hey, we're doing something weird. Okay, great. And those closures refer to different instances, so they're unequal. So basically for instance methods, because they're on 2 different instances, I guess we cannot be sure. No, they're just 2 instances, 2 different objects, so they shouldn't be equal, right? It would be probably different if we were comparing, you know, the type of this and type of that instead of something else. I don't know if we can do that. So return values. All functions return a value. If no return value is specified, the statement return null is implicitly appended to the function body. Ah. Okay, so it would just return null. To return multiple values in the function, aggregate the values in the record. Yep, there we go. Generators. So it just adds null. So I don't care about this code now. So let's see if I'm going to define some kind of random function somewhere. Let's say up above here. Some function, right? That will simply do print hi. We didn't specify any return value. Like literally nothing. We're just printing, and printing returns void, which is literally nothing. It shouldn't even return null in my opinion. So what now? I can do if some func is null, say hello. So this doesn't complain, right? It doesn't complain. It should print hi, hello. Okay, there we go. Hi, hello. But what if we're going to specify that this is void? Ah, now it complains. Okay, so by default, if we don't specify void, some function will be actually returning null. So it will be like, wait, null? What is the actual return type of this thing? Dynamic. Oh, I see. It just returns dynamic. If I were to return null, the return type is dynamic. If I'm going to return 1 to 3, okay, so if I don't specify it, it always ends up being dynamic? Yeah, okay. So that's good to know. It's by default, it's always dynamic. Only if I'm going to make it integer, then it's going to complain like, oh, you're doing something weird. Oh, okay. So it's not like TypeScript, which would actually infer the return value. This one just doesn't bother. It's like, it's dynamic. I don't care. It's up to you to figure out what the return type is. So that might be kind of nice and not nice. Kind of nice is that it doesn't, as a user of that function, when I'm using it here, it doesn't have defined return type there, and because I'm getting dynamic, that tells me like, hey, I should expect anything. And it's nice because if contents here are changing, I will still, as long as we don't change the definition, just the contents, I will still be just getting it dynamic, right? So the code you would, when you're using it, you would guard for everything. Like, is it a string that I returned or something else? The not nice thing is that if I had a situation where I was comparing it, checking if it's null, right? Because I had this code, but now that I actually start returning a specific value, as somebody who writes that function, expect that, oh, I made it obvious that I always return an integer. Therefore, everywhere in my code where I'm using that function, I would expect that I'm gonna get some kind of errors. Like, hey, you're doing something wrong. Something that TypeScript will help you out with, right? But no, here's just dynamic, so YOLO, you need to specify it. It's an integer. And only then it makes sense. Okay, that's good to know. What am I doing? There we go. Okay. I mean, good to know that it just appends null. Huh. Okay, let's move on to generators. When you need to lazily produce a sequence of values, consider using a generator function. Dart has built-in support for two kinds of generator functions. Synchronous generator returns an iterable object, or asynchronous generator, which returns a stream object. I really like that. Nice and simple. I'm used to something similar in C#, for example, but those return I enumerable or I async enumerable. Like, it has this whole pattern of slapping async in front of names. But yeah, this is great. Basically, streams are expected to be asynchronous. To implement a synchronous generator function, mark the function body as sync and use the yield statement to deliver values. So we'll return, that's different. Because I would expect that the moment I'm defining that it's iterable, I guess not, right? Because this just says that, hey, you're going to get an object that's iterable as a result. I could just return whatever here, make an object that's iterable, right? While this specifies that, hey, this is a generator, so we're going to get number 1 by 1. In that case, because it's asynchronous, I mean, it will probably just, over iteration, we'll just get 1 by 1 anyway. So that's not a big deal. So iterable, naturals 2, sync, and we do this, right? So we can do yield values. And the moment we exit the function, without yielding or whatever, or returning anything, we just finish, right? To implement an asynchronous generator. So before we move on to asynchronous, yeah, because then we have just other stuff. I want to check that with this iterable. So let's say that I define this, right? Naturals to whatever. But let me just think, maybe, because I want to do something that checks if it actually does it one by one, or maybe gathers everything and then executes in a loop or something. Iterable, a collection of values or elements that can be accessed sequentially. The elements of the iterable are accessed by getting an iterator, using the iterator getter, and using it to step through the values. Stepping with the iterator is done by calling iterator move next, and if the call returns true, the iterator has now moved to the next element. Okay, so basically, we could have two sets of it. Let's do the first one that returns iterable of integers, and this will be maybe get numbers list or something like that. We'll call it like that. Sure. How? Not even that. Just get numbers list, and we're gonna return a list of 1, 2, 3. Will that work? I guess yes, because a list is iterable. And the other one will be get numbers gen, whatever, or generate numbers. We'll have the same thing. We are going to actually start that we have a, numbers, which will be 1, 2, 3. Okay, so we kind of save them here. And then we're gonna do for number in numbers. Can I do something like this? Where's it? Numbers? Yield number. Okay, so I'm going to iterate over that, but just one by one. I expect to have same results. So let's do print, printing list. And we'll do, I don't know, get numbers list. We call it and dot for each. And we'll just say number. Wait, what am I doing? There we go. We'll print the actual number, right? So we're already using a lot. I just don't know if for each actually invokes action on each element of this iterable. Okay, so it takes an iterable, right? It's happy with that. So it should go one by one. So this will be printing a list, and then we're gonna have another printing from generator. And we'll just do generate numbers. Okay, and for each number, we're gonna just print them. So let's see what that looks like. Right? Looks the same. No big deal. But now I want to see what happens if I'm going to do something like, maybe, how about we have some kind of variable where we hold stuff. Let's say that it holds an integer, right? Integer, I mean, bar for variable, right? Current, whatever. Current number. will be 0, right? This is our current number. So when we get our numbers list, we just return them. So we can say current number is -1. Why not, right? And when we print a list, every time we do this, and in parentheses, we say current number. Okay, we're just going to add that. We're going to do the same thing in here. Okay, but in the generator, what we're going to do is that every time before we actually do stuff, we're going to say current number is number. Okay, we change it. So what I'm expecting is going to happen is that for this one, we call get numbers list. Therefore, it executed this whole code, and our current number will be -1, and then it just executes that on the already existing list, right? It just does that. Therefore, current number in the parentheses will always have -1. But what I'm expecting what's going to happen with generated numbers is that first, it calls this, right? Creates our list of numbers, and then goes all the way to here, sets the number to 1, because that's our first number, then yields that. And then what I would expect is that, oh, we got the first value, so we're gonna call this, and we're gonna print 1. Then we're gonna do, oh, so I need another number. And it's gonna go again, update it to 2, and print it. So it should be 1, 1, 2, 2, and 3, 3. That's how I'm expecting it to run, because the whole idea of generators, I believe, is that we're not waiting to have all the values already before calling the next function. This should be just taking the iterator and just calling get me 1, and hey, I want first number, so this one does that. Do something with a number. Get me another number. So let's see if this actually works. There you go. See, with this one, we got the -1, while this changed the actual outside variable every time it run. So perfect. It works as intended. That's good to know. And I believe that if we would have called to list here, what would happen is that this would say iterate over everything here and turn it into a list first. So by the time for each runs, it already has an existing list, which means the current number is already the last one. So the moment we'll be printing it, it'll be all 333. So let's save, run. There we go. We have all 3s. Okay, this is very intuitive. Very similar to how you would do it in C#, right? Or probably the same thing in JavaScript. Haven't worked a lot with generators in JavaScript, to be honest. Okay, so to implement an asynchronous generator function, mark the function body as async. So this one is sync, this is async. Okay, this is nice and simple. I like that. And use yield statements to deliver values. That's literally it. Okay, that's really simple. We just say that it's a stream. It's gonna create a stream for us. And there we go. We just do that. If your generator is... So I'm not gonna test this because I don't know how to deal with other asynchronous stuff yet in Dart. I guess this is all the way down here in asynchronous programming. But I'm sure it's gonna be easy to figure out, but it's nice that we can do it in this very, very simple fashion. Just replace your iterable with stream, and instead of sync, just slap an A in front of it, so we have async. And that's it. You don't need to change any code. So this could call, HTTP requests and whatnot. And yeah, love it. I can already see ways to make it smarter so that, because one thing with asynchronous streams is that if we look at this code here, let me just get rid of this thing. So the whole idea here is that this call doesn't generate any actual numbers yet. It just created that iterator that is providing the, like next. All it is, it provides the function next, or is there a next one? Therefore, we didn't start any of that yet. And here, the for each is smart enough that, oh, I'm being called on an iterator. So it takes that iterator and then it does, hey, give me next value. Therefore, this is going to run until the yield, takes that value, and does something with it, right? Once it's done, it's going to call again, hey, give me the next value. And this is going to do the calculations and go on until we run out of them. If we were to have a stream and make it async, right? The moment we have it as a stream, it will work the same way, all right? I don't know. This doesn't seem to complain. Maybe it's actually gonna work. It just worked, okay? So I didn't need to do any await. I presume that we have a separate for each separate version of for each that returns a future, okay? Whatever. It executed, we're good. But again, I expect it to simply do one thing and wait while this whole thing waits for the next thing. So the moment we finish this calculation, it will say, hey, now give me next. So therefore, it would do the HTTP request, and only when it returns, this will actually happen. So, it automatically waits. But what you could do in theory is, hey, I know that we'll be going over everything in here anyway, right? So how about I'm gonna, the first time it runs, it's like, oh, I don't have anything cached. I'm gonna run the request and return it. But the moment before it yields, it already starts another HTTP call in the background. This is an async, right? It just starts the future. It just saves the future somewhere. And while this is executing whatever it needs to the result, in the meantime, the HTTP request is, in progress. By the time it goes, hey, give me the next one, this one doesn't need to start from scratch. The HTTP request was already in progress. Therefore, it can use and just await that future. Maybe it's already responses in place and do other stuff. So this is how I would, for example, do a situation where you need to go over, let's say, chunk of data in a database. So while you're doing some calculations on the data that you just got from the database, maybe sending it to the database, right? You're already waiting for a next query to return. So you keep your database ready because your database can run multiple processes, maybe depending on this and that, you keep it busy, right? While your code is also quite busy because all this does is just waits until you get the thing returned. So just a little tidbit, a little diversion, but I can see that it's really easy to just deal with. So if your generator is recursive, you can improve its performance by using yield star. Ooh, that's interesting. So we have naturals down from, and we have this. It's synchronous. So if the number is larger than 0, we yield that number. And then after that, we just recursively call from this. So it just says we can improve performance if we're just, calling them one by one, like, recursively, but it doesn't say how it's improving performance. Okay, let's try this. We're gonna just say here. Can you explain how this works behind the scenes in Dart? How does it really improve performance? by adding the star. I wonder if it's gonna from the docs. Wonder if it's really gonna provide us with some value. I'm just gonna paste it like this, and we have this. Let's literally just slap on this. Okay, there we go. Let's go with Opus. Okay, well, this is thing we can read further because, hey, if you're dealing with recursive ones, just slap on a star and do it. Why doesn't it detect it itself? That's the question, because it should do it on its own if it detects that, hey, we're calling it recursively. So what does it change? Whoa, we got diagrams and everything. Why not? Okay, let's start reading. Explain the performance difference between yield and yield star or asterisk in Dart's synchronous generators. The key difference: when you use the yield star with another iterable, Dart delegates iteration directly to that iterable, avoiding the overhead of creating intermediate generator objects. Oh, so it literally doesn't create, hey, give me a generator of it, and I'm gonna generate over, I guess without this, we would literally need to just put a for loop in here, right? Okay. All right, so without the yield star, less efficient, yeah, we will literally need to iterate over the results. And that's how it works. Yeah, this creates a chain of generator objects. Each recursive call creates a new generator. Each generator maintains its own state machine, and values bubble up through each layer. Yep, so we just, if we put in, like, we want 2000 numbers, right? And we call it recursively, that means that we created literally 2000 iterator objects, which is just a bunch of data that needs to be suddenly garbage collected. With the star, first of all, our code is simpler because, hey, it's one line instead of doing this whole thing. It's more readable. And I guess it totally avoids the whole idea of, oh, I'm gonna create a new iterator. It just programs it in a way that kind of embeds it, right? So, hey, that's great. That's actually awesome. It would be nice to just have some more explanation of it here in the docs. So that's surprising. So yeah, values bubble up through blah blah blah. We don't need the diagrams. So this creates flattened structure. Generator gets directly to the nested, not intermediate. So therefore performance, memory reduces, stack depth, and generator object location. Oh, stack depth, that's another thing. Great. Eliminates intermediate iteration loops, and complexity changes from ON squared to ON. Wow, for deeply recursive generators. Okay, great. Implementation details. Behind the scenes, Dart's generator implementation uses a state machine. Look at that, we're going to learn something. So conceptually, the generator does something like class generator iterator. So we create our delegated iterator, right? Or at least something that will store it. So move next. If we already have the generator, the iterator, direct delegation, no intermediate processing, just if we actually got something, we do bam, the current one, return true, great. Otherwise not, and continue with normal generator object. Okay, best practice, always use yield star when yielding all values from another iterable. So this is good, this is bad. Okay, this is especially critical for recursive generators delegating large iterables, exactly, or performance-sensitive iteration code. Okay, so I like it. I very much like it. Good. It's good we learned about this. It's good we dug deeper. Great. Does this code do what I'm doing here? Because we generate numbers, right? For each number, we yield this. Not really. I mean, with the 4, we kind of iterate over those. So we kind of have that iterator. So in theory, what we could do is that, hey, we've got our numbers, and can we do yield star numbers dot iterator? I guess not. But okay, good enough. I guess it's not defined as an iterator, that's why. Okay, all right. Good enough. Okay, we're now finishing with functions. External functions. An external function is a function whose body is implemented separately from its declaration. Include the external keyword before a function declaration, like so. Okay, separately from the declaration. So external void SumFunc. An external function's implementation can come from another Dart library, or more commonly from another language. In interrupt contexts, like external introduces type information for foreign functions or values, making them usable in Dart. Implementations and usage is heavily platform specific, so check out the interrupt docs on, for example, C or JavaScript to learn more. Okay, makes sense. Pretty simple. External functions can be top-level functions, instance methods, getters or setters, or non-redirecting constructors. Yeah, we haven't learned about constructors yet. That will be in our classes. An instance variable can be external too, which is equivalent to an external getter, and if the variable is not final, an external setter. Okay. Great. So we finished with functions. I think we actually learned a lot. I really am happy with the generators. The weird quirk with return values being dynamic. How to deal with lambdas and whatnot. One thing I wanted to check, can we actually throw in curly braces with lambdas? I don't think so, because, I mean, we have the curly braces here, and here, right? We have this. We either do this return, right? Or maybe not return. So there will be no point of doing this. That will just add even more stuff. This just called it here, and therefore this is unhappy. It's like braces unnecessarily wrap this expression in a set literal. That's just a warning, right? Yeah, so this is like, you're doing weird shit. Don't do it. Print hi. Still doesn't like it. Try removing the set literal around expression. So otherwise, I would just do this. Yeah, and that's fine. Just slapping on an arrow function is just pointless. We either have this with one single thing, or we do the braces. Okay, I like that. Simple enough. Yep. There we go. Okay. So let's move on to the big subject, classes, because we have a lot to cover here, looks like. Classes, their constructors, methods, extending a class. We have concept of mixins, which is interesting, I guess. It's a very fun concept. Enums, extension methods, love extension methods, and extension types, whatever that is, and callable objects, which is strange, but I guess useful. Okay, so let's start with overall classes, because it's a big subject and seems like a big part of Dart. So yeah, let's learn the tools. So classes. Dart is, oh wow, we have like sections here. Dart is an object-oriented language with classes and mixin-based inheritance. Every object is an instance of a class, and all classes except null descend from object. Okay? Except null, right? Mixin-based inheritance means that although every class except for the top class, the object, has exactly one superclass. Okay? One superclass, which is like whatever, one parent. Unlike in real life, classes in Dart have only one parent. A class body can be reused in multiple class hierarchies. Okay? Class body can be reused in multiple class hierarchies. What the hell does it mean? We can define two separate classes inheriting from two different places with a single body. What the hell? Extension methods are a way to add functionality to a class without changing the class or creating a subclass. I absolutely love extension methods. This is like the best feature, for example, C# has, in my opinion, because it enables you to really write nice and clean code without doing some weird gymnastics, creating random extra classes or wrappers for things, and makes configuration and overall builder pattern really easy to use. And then we have class modifiers, which allow you to control how libraries can subtype a class. Excuse me. Okay, so using class members. So objects have members consisting of functions and data, methods and instance variables, respectively. Okay, so they call them methods. So we have distinction between a function and a method. A function being just a function, while method is a function that exists on a class. Okay. And then we have instance variables. Great. They don't mention static variables, but I guess just, yeah. When you call a method, so let's continue. When you call a method, you invoke it on an object. Okay. The method has access to that object's functions and data. Use a dot to refer to an instance variable or method, right? So we have a point that's 2 and 2. So I guess we create an instance of a point, right? With those two values. And we can get a value like, hey, we know the point has a instance variable y, so we just get y. And it should be 2. And invoke distance 2 on p. So we do p and we call the function on it distance 2. And we give it another point, and that basically knows that, hey, I'm being called on p, so I have access to its values. We don't have to pass it in here like another argument, and that's a nice thing. Use question mark dot instead of just dot to avoid an exception when the leftmost operand is null. So if p is non-null, set a variable equal to its y value. Excuse me. Okay, so if p is non-null, set a variable equal to its y value. Otherwise, it just doesn't do that. What is a if this is null? Let's try that. Do we have roughly how we can define something? A class definition, getting object type, whatever. There we go. Here we have the point class. Great. So, class members. There we go. So let's do this. We have our class point. Let's just do 0 and 0. So these can be nullable, right? And we have double this, and we have some kind of constructor, I guess. Let's try it. So let's try to make final point A, which will be point 1 and 1, or 1 and 2, okay? Okay, that worked. Final point B will be point. Can I do that? No, I need to specify them. So what if I'm gonna make it null, comma, null? It allows me to do it. Okay, that's great. So now let's say that final point C will be something like if I don't know, x is 1. So let's do variable x is 1. Okay. So let's say if x is 1, I forgot the syntax. If x is 1, we just give it. What the hell was the syntax? Let me just quickly check because we were going over that and I recall all that. Branches. If we have if something, return something, right? But we also had statement, exhaustiveness checking, switch expressions. So it was somewhere here. If this, do that, blah, blah, blah. If case, Dart if statement supports case clauses followed by a pattern. Yep, that's fine. Flow progresses, blah. The if statement provides a way to do destructive. Wait, we don't have the expression? Because there's switch expression. Huh. And this was just no else, right? Can I do that? It'll be point A. Else, return point B. I mean, I can't see that working. That just doesn't make sense. This is like, ew, ow. I mean, we could just do this, right? And why do I even bother with if we have Turner expressions, right? So that's our point C. So what I did here, but with this X, is I'm hoping that this doesn't know if it's point A or point B, could be null, could not be null, and we'll be able to check something. So now we had that example of here. Set the value of A depending if this has that or not. So let's say variable A is point C dot X. Okay. Right now, it's gonna be just nullable double, right? What if I'm gonna do question mark dot? It's unhappy because the retriever can't be null. So the null aware operator is unnecessary. Try replacing the operator with this. So it just, it's like, this doesn't make any sense, right? The value of the local variable A isn't used. Try removing it. Yeah, I'll just print A, whatever. So this just says the receiver can't be null. So the null aware operator is unnecessary. So what if I'm gonna make it that this needs to be, what was it, integer? No, double. Now it's like a value of type double can be assigned to a variable. Oh, okay. We don't do exclamation mark here. We would need to do something like this. Or I recall it being something with exclamation marks. But X is basically always a nullable double, so we would need to do stuff. Okay, I see. So we can do that, but this example just doesn't make any sense. Okay. Weird, maybe I'm missing something. So using constructors, you can create an object using a constructor. Constructor names can be either class name or class name.identifier. Okay, because we have some like named constructors, right? For example, the following code creates point objects using the point and point from JSON constructors. So we have normal point constructor that we just give values, or point dot from JSON. So so this looks like, normally when I look at it, it's like, oh, we call a static function on the point, but I guess which is I guess a common pattern to have like more custom constructors in various languages, because yeah, in C# you would do like, oh, I want to create something from a constructor. I'm gonna define static function that creates that object and then returns it, and therefore I have something that acts as a constructor. But something tells me, because we have the syntax, that means it will probably make it a little bit easier to actually create the object from the perspective, instead of us doing like, oh, we're gonna do this workaround of static functions or something. So the following code has the same effect, but uses the optional new keyword before the constructor name. So this is like optional. Okay. Some classes provide constant constructors. To create a compile time constant using a constant constructor, put the const keyword before the constructor name. Okay, great. And that will create a mutable point. Okay. Constructing two identical compile time constants results in a single canonical instance. Yeah, that's the nice part, right? So great, they're identical. So I guess there's some extra restrictions in how you construct your class. So this is all about using those, not how you define them. That's interesting. Within a constant context, you can omit the const before a constructor or literal. For example, look at this code, which creates a constant map. So constant point and line is, we create a constant, which is an what do you call it? An object that, or a map that has point. This is a constant list of constant immutable. There's so many constants, right? But you can omit all but the first use of the constant keywords, because the moment we call for the constant here, right, it already is like, oh, you can't assign anything but a constant map that maps to constant lists of constant objects, right? We kind of force everything to be constant. Looks like you can't have a constant list with some kind of random changeable things, because constant is not like in JavaScript where it's runtime only. This is actually compile time. Therefore, the value will be like evaluated, compiled during the compile time, and therefore it simply cannot change. So that makes sense. That makes it nice and readable. If a constant constructor is outside of a constant context and is invoked without const, it creates a non-constant object. So this creates a constant. This does not create a constant. Okay. So basically, you won't be able to compare those two, or if you create B and C with the same but without const, there will be two separate objects. So we'll just always create a new one, instead of this being pre-calculated to be always the same instance. Okay. So getting an object's type. To get, and we have doing code like I should. Do you read chats? Yes, I do. Not just documentation, I also read chats. That's all I do, just read. Alrighty, getting an object's type. To get an object's type at runtime, you can use the object property, runtime type, which returns a type object. Okay, so print the type of A is, okay, so A dot runtime type. So looks like every object has this property, runtime type. Okay, so yeah, so let's say we have point A and point B. And if we want to, let's just ignore this whole weird stuff, right? We could print that, let's say, final are equal. And if we're gonna do point A compared to point B, and my current understanding is that we simply are comparing the references, and this points to a different object than this, therefore it will be false. Okay, so are equal, and the value will be, in my opinion, false. So let's see. There we go. It's false. If I would say, point A to point A, it'll be obviously the same. Or maybe let's do final point C, which is point A. And therefore, we should get true right now. There we go. Because it points to the same instance. But I want to check for this runtime type, because they should be both the same, right? Point A dot runtime type should be exactly the same as point B runtime type. And because, it's the same thing. And we have true. There we go. What does it look like if we're going to do print runtime type of point A? Point A dot runtime type. What does it print like? Point. I mean, that's true because it's just a class. Okay, so it just says, hey, this is the class point. And that's literally it. Okay, what if I'm gonna do a list of points and take this as that? So we have list of point. Okay, so this is nice and readable. Awesome. I like that. No weird cryptic names or whatever. Lovely. Warning. Use a type test operator rather than runtime type to test an object's type. In production environments, the test object is type is more stable than the test object the runtime equals some specific type. Ooh. So, it makes sense. It makes sense where we're comparing a type of this one, a same type as that one, right? That makes sense. But if we just want to have an if statement, so if point A is point, right? Then we're gonna do something because it could be in theory something else, right? So this will be better than doing if point A is the same as point. I guess you could do that, right? That's what they're showing. Wait, point A dot runtime type. Yep, that's what I say. You could do that, but no, don't do that. Just do is. And you can see that we already have it, like, even compiler knows, like, hey, this is an unnecessary check because it always happens. While here, it can't figure that out because we're literally calling some kind of function. So this could return any kind of type. We don't know what's going to return, so we will compare it to, I guess, the type. I guess that's how it works, right? Runtime type. We can't do that because it's not an instance, right? The getter runtime type isn't defined for the type point. Try importing library. Yeah, okay. I guess that's how we would make a comparison. So who the hell knows? But okay. Alrighty. Up to here, you've seen how to use classes. The rest of the section shows how to implement classes. Finally. Waited for so long. Okay, so instance variables. Here's how you declare instance variables. Well, here's how we declare class in the first place, right? We use call class point. So the keyword class and the name. And then we have the brackets, and then we put the contents in. And no comma, no semicolon at the end. All right. So how to declare instance variables? We define it like this. So we have the type and value. Declare instance variable x initially null. Declare y initially null. And declare z initially 0. So my understanding is that if we're going to get our point and we're going to say that we have int magic value, if we're going to do that, it doesn't complain. But it complains that, hey, non-nullable instance field magic value must be initialized. So if we're going to say that magic value is 42, it's set by default already. So we don't have to specify it here. It will always start with a default value. That's it. Okay, that's simple. Simple enough, makes sense. An uninitialized instance variable declared with a nullable type has the value null. Non-nullable instance variables must be initialized at declaration. Or in the thingy, right? So let's get our magic value back without the default value. We're gonna say that this x, this y, and this dot magic value. And now it's happy. No big deal. We just need to set the magic value every time. There we go. And doing code says, I'm a senior backend developer who loves to create APIs. I want to switch to Flutter development. I'm just learning Dart for the first time. I mean, it's a fourth live stream, but I'm literally just reading the documentation. I heard good things about Flutter, so you might find it fun. Yep. Yeah, try it. Dart is pretty nice. What kind of language-wise backend were you doing before? Because maybe I can draw you some parallels to how you would feel about Dart. Okay, so this is kind of not true, but whatever. All instance variables generate an implicit getter method. Non-final instance variables and late final instance variables without initializers also generate an implicit setter method. So non-final instance variables and late final. I already forgot what late final is. I guess it's going to be evaluated only when used? Or it was something like, oh, we don't have to define it. It was something, don't remember. TypeScript, Node.js, and Python fast APIs, says doing code. I don't have a lot of experience with Python, although, you don't have types, so I guess the closer will be TypeScript. So you can expect Dart to be... You won't have as much expressiveness with types. You can do some weird conditionals, so that will feel initially limiting for you. But at the same time, I have a lot of experience, for example, with C# and TypeScript. And I know that because this is, it doesn't have this weird, crazy duck typing like TypeScript and all the weird, I'm gonna test for part of something or whatever. It feels much lighter, and at the same time, it really makes you feel safer when you're typing code here, because it's like, oh, I typed it in, it instantly shows you what's wrong. You don't have to worry about some edge cases. You will really like it. You will really like enums here. And I think from the API perspective, the moment you get through the fact that you need to do some extra work to maybe, convert from this object to other object. Like when you get stuff from the database and you suddenly need to pass it out to, as a response from your API, you need to drop some fields, right? In TypeScript is relatively simple. You can just filter them out and you're good. Here, you would actually need to have a separate types. One for whatever you're getting from the database, or maybe dynamic, because you kind of can do JavaScripty things. And one for the actual return thing. They are, you can't just convert from one to the other while it's still being the same object. You need to actually, kind of transfer them, turn them from one to the other, and use something that does the mappings for you and whatnot. So it might seem initially as more effort, but what you get as a result is that you're suddenly sure that your code will work. as long as there are no errors in compiling, you can be like, yeah. And yeah, Taras says class modifier section is carnage. I'm really looking forward to the class modifier section, but it's a separate thing. I need to see a little bit. Abstract, base, interface, abstract interface, final, sealed. Okay, that's it. No modifier. Good abstract. That's normal base. Okay. We've got interface. Great. Interface class. That's interesting. I guess that's how we... Oh, so there's no separate interface. We just define interface class. Okay, that makes sense. Abstract interface. Okay, that means by default, our interface class can actually have implementations. That's interesting. I guess that... Okay, and we have separate abstract interface. Okay, makes sense. Sealed, yep. And what else than sealed? Final. Final, this prevents subtyping from a class. Then what does seal does? To create non-enumerable set of subtypes. Oh, interesting. I don't think this is crazy. I guess as C# developer, this is normal. This is relatively normal. Nothing scary. Doesn't Kotlin also has that? Also combining modifiers, absolutely, yes. I mean, you can't make sealed and abstract, so no biggie here, but I can imagine you can have sealed interface in that case. I wonder if you can make sealed abstract interface, because that should make that actually makes sense. So yeah, is there an example of sealed? Blah 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 blah. Where's the sealed one? Oh, sealed class vehicle. That shouldn't work. Oh, you can define them? Okay, so that's probably different than final, right? So final class vehicle and can be inherited. Oh, there we go. But it doesn't say anything about... Yeah, so this might be a little bit lackluster here, but yeah, I get what's going on. Now we get table of combining. There we go. The class, base class, that changes it, that implement, we don't have to have it implemented. Okay. How does it differ from abstract class? Construct. Oh, okay. So we have, can we construct it? Can we extend it? Can we implement it? Is it a mix-in or exhaustive? Mix-in is only for those marked with mixed-in. Okay. So class, base class, interface class, final class, sealed class, abstract base class, abstract interface class, abstract final class. And then we have a bunch of mix-ins. Okay, not too bad, not too bad. I think when you understand each keyword, it makes sense. No biggie. I'm not scared. So let's see. I'll finish with, I'm using TypeScript since 4 years. Says doing code. I'm from India. Bro, chill. Bro, ignoring messages like her. I'm not ignoring your messages. Just, 2 separate threads. Alrighty, let's get back to our, what we're doing here. Classes, we went through that. We were going through, defining our instance variables. So let's read through that again. So all instance variables generate an implicit getter method. Okay, so basically, so we have like get x, or does it mean, wait, declare instance variable initially null. Use the getter for the method x. So by taking it like that, they say you're using a getter. Okay, I guess in the background it kind of pretends that it has a getter. Okay, and then we have that one, initially null. So use the setter method for x, and default to null. No big deal. I don't understand why we're dealing with like, oh, we have a getter method. Unless it's final, then we just can't set it anymore once it's being created, right? Which, how does final work here? So we can just slap in that this is a final int magic value. Okay, that will just mean that once we create it here, we won't be able to set it. Once we do this, let's say it's 42, we know that even within like a function here where we would have, do we have to define like word function? I don't think we need to use the word function here. So if we're do set magic value, right? If we're gonna do, let's say this would be void, and we don't even provide value, and we'll try to do this dot magic value is, I know, 23. It will be unhappy because, hey, you can't set it, right? If we'll just make it non-final, then of course we can. Okay, makes sense, no big deal. Therefore, they're just trying to formally say that, hey, if the non-final instance variables and the late final instance variables without initializers also generate an implicit setter method. Okay, so if I'm going to do this and just not set a value, right? Behind the scenes, it says like, hey, there is a setter. Wait, let's make it final. So in theory, it has the setter. We can provide a magic value. I mean, this dot magic value, right? So this will use that setter, but we won't be able to use it again. That's all it is. Meh. Overexplained. As they're not they don't provide a lot of info here. Yet here they just overcomplicate things. And then we have late final. So how would late final work here? Late final. And if I'm gonna do this, suddenly it's happy. So does it mean that I can just do some magical stuff with that? Like it'll be one time set from the outside? Because that will be fun. Tara says, it's a big deal as you can change behavior of getter method later versus other languages like JavaScript where you would not be able to do that. So you can change the behavior of the getter method later. What do you mean by changing the behavior of the getter method? Okay, so I wanted to test that we can create object like this and that, compare them, and this should run happily, right? Even though we didn't set the magic value anywhere. Run and it's happy. So I guess if we'll try to do print magic value of the point B, let's say, point B dot magic value. Oh, wait, I need to do this fun thing. I mean, it allows me to run it, but I expect I'm going to get runtime error. There we go, runtime error, right? Beautiful. But that means that somewhere here before that, I can say point B dot magic value is this, right? I should be able to do it, and now we'll run. There we go. But if I'm gonna do point B dot magic value is 1, 2, 3, compiler doesn't care because I guess late makes the compiler just freak out and ignore stuff. But I should get an error here, right? The second time, oh, it's already been initialized. Okay, I can see that. This is useful. I like to be able to set something outside of the constructor just once. I mean, it kind of looks like we can introduce risk of just runtime errors, which is bad. But maybe for something internal within our saved code for some library or something could be useful if it could simplify some stuff. Yeah, I guess. Wonder what kind of implications it would have for performance. I know that's probably the only point I can see, that if this improves performance in some way that I don't need to run some additional checks or whatever, maybe, I don't know. Tara says there's two kinds of late: set or not set. Set would lazily initialize on first access. Not set would only allow to set itself once. Change behavior of setter. Add extra code to refuse setting provided value, or modifying provided value before setting it. Okay, so you're basically with the lazy. Right now we have the type that is not set, therefore we were able to do it somewhere. Or if we have it actually set as 42, it just doesn't really hold the value for some reason until we actually access it. So if we were probably to create some kind of list of something, right? Something that's not constant, it wouldn't initialize a list until we get it. So basically our getter behind the scenes is a function that knows that it will create this thing. And when we access it the first time, it kind of creates it for the first time, saves it, and okay, now we hold the value. And therefore it changes itself afterwards into providing the existing value rather than reevaluating it. Okay, I see. And therefore we probably have a reference to a function instead of some kind of if statement in there. Okay, it hands a bunch of functionality. Okay. If you can have a function call instead of 42 for lazy. Or you can have a function call instead of 42 for lazy. Yep. Oh, as in I could do something like this? No. Function call. I can do a function call. There we go. Okay, that works in this language. Good. Sure. Okay. I see. and therefore we won't execute that until something. Yep, makes sense. All right, I learned something. Thank you, Darius. Alrighty. So we went through the late finals and whatever. So for details, check out getters and setters, which will be not here. Where is getters and setters? Oh, and send methods. Okay, we'll get there. We'll get there. We went through this and there we go. So our class point, declare instance variable x initially, declare y initially null. Okay, we went through that. Initializing a non-late instance variable where it's declared. Wait, initializing. Oh, we'll have more about late here. Instead of me figuring it out myself. Okay. Initializing a non-late instance variable where it's declared. Okay, so something like this equals something. Sets the value when the instance is created. Okay. Before the constructor, and its initializer list execute. Okay, so basically, because I presume we can have constructors that are a little bit more constructive than than something like this, where it's like a default, oh, I'm assign this to that and this to that, where we actually have some kind of implementation. And therefore, looks like, we initialize default value, and then depending on some other values in the constructor, we could modify it. Therefore, this happens before the constructor, then our constructor runs. Okay. As a result, the initializing expression after the equals of a non-late instance variable can't access this. Okay. So non-late instance variable can't access this. Oh, I see. So with our late variables, it could be kind of useful to just give it the, oh, I see. So that actually makes sense. So let's say we have our late final, right? A magic value, which really is this dot x plus this dot y. This will be our magic value. Right now it's upset because we can't get it directly, right? Oh wait, it actually isn't. So it's just like, hey, this is double. How the hell the conversion work? I already forgot. Can we take this dot ceiling or floor? We'll round it down. So this isn't happy. The argument, because these are like this. Just screw the question marks. We're not dealing with this BS. Okay, so I can define something like this. Straight up here, I can use this and that. But here I can't do this dot x, right? It'll be like, oh, sorry, this is not late, right? So I like that. This saves us from wrapping it in a function. Okay, lovely. We can have something that reevaluates, because something that I would like, the equivalent of this in C#, for example, would be where I would have, I don't know, read only, or I don't even need to deal with read only. It will be integer magic value is, and I would say the get will be, and here I could basically say that, hey, the getter will be, if it's already initialized, right, do this. If it's not, if it's not initialized, maybe actually get it from those. Although no, here I wouldn't have to, because it's a getter, so I would just say that all I need to do is, return this dot. Yeah, I could just do this, right? So I don't need to do anything, and that's already read only by itself because it's just a getter. And it's final because it just has a getter and I didn't specify a setter separately. Okay. That's okay. Okay, I'm just drawing parallels to those two things. All right. Makes sense. Okay. As a result, initializing expression, yeah, we don't have access to this. So point, okay, can access declarations that do not depend on this, right? Initial X. Yeah, it just takes it because it's a top level, right? Oh, this poses a question. Huh. What if I want to see that? What the hell? Let's say we have a variable called exclamation, okay? And we're going to say that it's a string banana, okay? That's what we're going to do. And therefore, our magic value will be a string, not late. It's just a normal string that we say it defaults to the exclamation, okay? And we can just create a point, A, and therefore we're going to do print point A dot exclamation. Oh, wait. Sure, magic value. Okay, we're gonna print that maybe with a nice plus, and we're just gonna slap an exclamation mark after that. All right. And then we're gonna do the same thing for point B. In theory, they both should just say banana. Okay. So what if in between them, I'm gonna say that, hey, exclamation is spoon. Okay. Okay, it changed. So suddenly the creation of the class, the process of creation of the class changed. Ooh, that's interesting. Okay. All right. I'll keep that in mind. Okay. So instance variables can be final, in which case they must be set exactly once. Initialize final, non-late instance variables, add declaration. Non-late instance variables add declaration. Okay, so if it's non-late, we have to declare the value here. Using a constructor parameter, yeah, we tried that, or using a constructor's initializer list. Initializer list. Oh, we have yet different syntax. Okay, and okay. Oh, so this is like a default one, so we specify here that this is supposed to be that. Okay, that makes sense. I see the value of that syntax. But at this, yeah, okay. Because if we were to, set it somewhere, it would be like problematic. If we want to have different default values, so in theory, we could have a 0.0, right? So maybe we want to actually do our immutable class. Which will be final double and final everything, right? We ignore this whole. Oh, we already had Z here. What the heck? I never saw this. Come and hit it. So look how this is unhappy because we're trying to set the points, right? And we already have the default values, so we can't do stuff. So here, if we're gonna do this, must be initialized. I mean, I am initializing it. Oh, immutable point. There we go. So I'm initializing it, right? But what if I want to have immutable point dot zero, right? The common pattern that I don't want to provide anything, and I'm always gonna get that kind of static thing. What the hell is this? Completions, you're on, oh, just errors. Yeah, whatever. So that means I can say that x, and how do they say it? X is 0, y is 0, right? And something like mutable point, let's say to the right, would be x is y, 1, y is 0. And this way we can just do those things. But the thing that I'm thinking of is like, that probably doesn't create like constants, because it would be nice to have those constants, but maybe it doesn't matter. So suddenly beyond that, we can just say, final point C is immutable point dot 0. And we just have everything properly initialized, right? And therefore, we don't say that, oh, this is always, some value. We can kind of provide various things. Okay, I like that. Or we could probably do, let's say, I mean, that's kind of stupid with immutable, but why not? No, it's not stupid. It's not stupid. Let's say immutable point, and this will be something like, Tara says, okay, see, you're getting a headache. I hope it's not from me. This is starting to be fun. By whatever, just x, right? And we'll say that we provide this dot x, and can we provide that y is always, let's say, 0? We can. Okay, so this is nice. This is nice. I like it. Hopefully we'll have something more complex here to play with soon. Okay. The constructor parameter, or okay, so we'll learn about that. If you need to assign the value of a final instance variable after the constructor body starts, you can use one of the following. Use a factory constructor, interesting, or use late final, but be careful, a late final without an initializer adds a setter to the API. Exactly, therefore we could try to do something from the outside, and that can cause issues. Big issues. All right, so let's move on. Tara says, just stressful week and Friday evening. Sorry to hear that. Have a good rest, and I hope your weekend will be less stressful. Okay, implicit interfaces. Every class implicitly defines an interface containing all the instance members of the class and of any interfaces it implements. Okay, if you want to create a class A that supports class B's API without inheriting B's implementation, class A should implement the B interface. Okay, I recall that. A class implements one or more interfaces by declaring them in an implements clause, and then providing the APIs required by the interfaces. For example, we have a person. The implicit interface contains greet. Yep, so we have the person and the name in the interface, but visible only in this library, I guess because of the underscore. Not in the interface, since this is a constructor. Wasn't it that the library is literally just a single file? So it will be visible only within the single file until we go into partials or something. Okay. And not in the interface, since it's a constructor. Of course, we can't. Yeah, constructors don't belong to the interface. They belong if that was an abstract class, I believe. And then we have in the interface, which is just the greet, right? An implementation of the person interface. So class imposter implements person, right? Implements, not extends, just implements. So that's how we learn about how to implement interfaces before they're introduced. Okay. So string get name. Bam. So we can call this within here, have access to name because we're within the same library. Okay. And then we can implement the greet, which is this. Great. Therefore we can do greet Bob. We give it a person. There we go. Beautiful. We can call it the same on imposter. That just doesn't set the name. Lovely. Kind of strange. Wonder how it becomes with testability, because on one hand you want to have explicit interface, but on the other hand, if you just have one implementation and you expect to have only one implementation of this kind of thing, you can still, you don't have to duplicate your code like, oh, this is my interface and whatnot. You can just create a mock of it very easily without, explicitly having separate file with an interface. So it's kind of fun. Okay. And you'll define an explicit interface only when you're actually planning to reuse it here and there and whatnot. And therefore you have more control that, oh, this is just this method, this is just that method. Okay, I kind of like this implementation. This is fun. I can see the value of this. And it's not like, oh, this is hard to read, like what the hell's going on? Implements, therefore interface, and class name. Okay, we're gonna use the interface of it. So that's good. And states type safe. The rules are relatively simple, so it's all good. Here's an example of specifying that a class implements multiple interfaces, right? So we have implements comparable and location. Beautiful. So, and what if they both have greet? How does that work? I want to see. I want to know. So we have class person, right? And we just have void greet and say, let's say name. And what it will do, it will just print hello, whatever name, right? So this is our person. And then we have class, maybe, I know, animal. Void greet. I mean, we'll just do the same thing. We'll just say animal sounds and just throw in the name, right? For now, we have the same way it looks. And therefore, we want to say class, something that implements both interfaces. So will be, I don't know, it doesn't make any sense, but let's say, prof, whatever. Professional reader. Okay. Implements person, animal. Okay, now it's unhappy because missing concrete implementation of class person greet. Just person greet for now. So let's do welcome something. right? And it looks like it passes for both, right? Because it's the same interface. What if animal doesn't have anything? Now it's like, oh, is an invalid override of animal greet. Can I have two of those? Like one like this? No, I can't. Person.greet. How do I resolve it? No? Do we have like ability to have two in the first place? Let's say person sounds? No. This is already defined. Trying to naming one of the. We don't have function overriding or not overriding. Whatever. Oh no, the language suddenly became not fun anymore. Oh no, we need to deal with like optional and stuff. Oh dear. Oh dear, oh dear. This is bad. Boo. Okay. We just learned that Dart has big limitations. Okay, let's move on. Class variables and methods. Use the static keyword to implement class-wide variables and methods. Okay. So just static. Yeah, static variables. Static variables, as in class variables, are useful for class-wide state and constants. Okay, so they can be constant, right? But do they have to be constants? So static variables aren't initialized until they're used. Ooh, that's... I mean, that makes sense. The question is... Okay, I want to make a test. I actually want to make a test. So let's say that... Let's get rid of this. Let's say that we have class... you know, something, okay? Doesn't matter what it is. What matters is that it will use the exclamation, right? So we'll say static string exclamation is this. So we're pointing to this, okay? This will be our static variable. It can change whatever, or maybe static final. There you go. We're setting it immediately. And then we're gonna have another static final string second exclamation. So let's do first and second, okay? We have two separate exclamations. And that's it. They're just static, final, and nothing else. So what if... I'm gonna get rid of the point. Doesn't matter anymore, just clouders. So what if I'm gonna say print exclamation, which will be something dot first exclamation. Okay? And then we're gonna do the same with, well, with the second one. Exclamation 1, exclamation 2. Okay? So that's clear. I'm gonna run it, and we should have banana, banana. So the way it works in C#, for example, is that the moment we actually reached into static value of something, we initialized both. That's how I would expect it to work in C#. This text suggests static variables aren't initialized until they're used. Not until any of them is used, until they're used. So let's just make sure. If I'm going to specify that exclamation here is spoon, I would expect that the second exclamation still has banana and doesn't change it to spoon. Run. No, they both like that. Oh no, so they're just only one by one. That's interesting. That's very interesting. So that means that the moment we run this one, we reach the first exclamation, only this one is being calculated. Even though it's not late or anything, this one got calculated, but this one didn't. And therefore, only when we do this one, we calculate it, and therefore it changed. Ooh. So you kind of can't rely that when you do something, touch the whatever, the something class, this static thing, that it's gonna do something. Can we do static class? No, it doesn't have that feature. Okay. Huh. Very interesting. That means that even for final, right? It will be the same behavior. Yeah. That is very surprising. I did not expect that, to be honest. Huh. So that means that they are kind of encouraging that, hey, maybe you can make some kind of larger class that holds, a bunch of static things, that maybe each one of them. But now what? Oh, I see. So one could say, let's make them final, right? Just like before. So what if I actually had it where it calculates something? It's not just a constant here. Maybe I had a function that just returns a string, and this would be to be get exclamation or get current exclamation, right? And it will just return the exclamation. That's it. Can I actually do this? Okay, it doesn't mind it. Can I do static string get current exclamation? That calls get current exclamation. Why not? Can I call this? I can. And the result should be still the same. Okay, so that means that, let's say we have this thing and this is something maybe, provides number 2, number 3. It allows for int whatever, right? We can do that, no problem. And therefore, they'll be just evaluated separately. We could probably even do something like print getting current with, and let's do value. The body might complete normally, causing null to be returned. Oh, return. Okay, there we go. So it runs them one by one. That is very, very, very curious. Yeah, so you could make like a big configuration object so that whenever we reach out to this specific type of configuration for the first time, then it's gonna get fetched. And it won't try to do, let's say you defined 50 different values. This is gonna reach, the moment you get the first one, it won't try to evaluate all of them. It's just gonna do only a single one. You still have the comfort of having it, might be config, right? You have this class, you have only static methods on it. So in C# that will be static class. Therefore, you can reach out those values everywhere from your program, right? You can consider a singleton, but everything is static. Therefore, you can't have multiple instances. You just have one thing. And therefore, you reach out for first element. It doesn't evaluate everything. It doesn't have to hang, for a long time to evaluate everything. You do things in chunks. The only thing is, if this relies on something else, and that something else, by changing it, might influence this. This is very interesting. Very, very, very interesting. Huh. This page follows the style guide recommendation on preferring lower camel case for constant names. Okay, good to know. Am I naming them correctly? Yes. Okay. And of course, constant is different with static constant. This won't work because, oh, sorry. Constant? No. It's just, it just doesn't work. Yeah. Oh, well. Oh, well. Oh, another thing is from within here, I guess we can get the first exclamation. Oh, we can do that. Ah, so, if we're gonna run it, wait, I have was something, right? The banana and banana, because this takes it from here. But what it means is that I can actually get rid of this entry, and by calling this second exclamation, I will actually make the first one to be evaluated as well, right? Yep, they're both spoon. Okay, good to know that we can kind of rely on both of them, and one calling the other will kind of cascade. So we don't even need to use anything like late or anything, just simple final is good enough. Okay, interesting. Okay, static methods. Static methods as a class methods don't operate on an instance and thus don't have access to this. They do, however, have access to static variables. As the following example shows, you invoke static methods directly on a class. Yep, so we have class point, we have double, and we have a constructor and class is static double, distance between, and we have point A and point B. That just calculates it. It has access to A, B, and I mean, it doesn't even reach for anything because we don't have anything static, okay? Therefore, we can say this is our point 1, point B, and distance is point dot distance between. Question mark, can we do A dot distance between AB? That's the question. Let's try this. Let's actually copy the whole thing. We don't care about this example anymore. So we have this code, right? If we run it, we have some value. Great. But can I do A dot something? No, the static method distance between can be accessed through an instance. Okay, so that's again a difference compared to C#, where in C# I could call static methods in this way. So, okay, this is a little bit more restrictive. It makes it clear that we're calling a static thing, which is fine, I guess. No big deal. There's not much use to call them through an, instance. Although it is if suddenly the static method maybe notifies or something or whatever. Who the hell knows? But okay, no big deal. Note, consider using top-level functions instead of static methods for common or widely used utilities and functionality. Okay, yeah, because then we don't have to kind of construct it, and I guess this is a little bit slower if we're going through static methods. But at the same time, we have tons of stuff and you want to group them. But at the same time, I can just group that normal top-level functions within the modules, whatever files, libraries. So, okay, I see. All right. You can use static methods as compile time constants. Okay. For example, you can pass a static method as a parameter to a constant constructor. Okay. All right. So let's move to constructors. I guess this is where we're going to finish tonight because this is a lot. And yeah, it's nearly one on my end. Okay, so let's learn about constructors because so far we saw only a little bit and we have tons. Constructors are special functions that create instances of classes. Dart implements many types of constructors, except for default constructors. Except for default constructors, these functions use the same name as their class. Okay. So generative constructors creates new instances and initializes instance variables. Okay. Default constructors use to create a new instance when a constructor hasn't been specified. Ooh, it doesn't take arguments and it's named. Oh, okay. I mean, it isn't named. So, does it mean that in theory I could have my point, right? That has double x, double y, right? This isn't happy. It's not initialized, but the moment I have it as 0, and this as 0 as well, it uses the default constructor that doesn't have an arguments because it can be used when everything has default value, and therefore I can say var a is point and print a. There we go. It worked. A dot x, let's say, should print 0. Beautiful. Okay, so we have those default constructors. Good to know. So next we have name constructors. Clarifies the purpose of a constructor or allows the creation of multiple constructors for the same class. Then we have constant constructors. Creates instances as compile time constants. It will be good to learn more about this compile time stuff because it could speed some things up, especially that, as long as it's constant, suddenly we're dealing with sharing the instances of the same thing between a lot of stuff. Then we have factory constructors. Either creates a new instance of a subtype or returns an existing instance from cache. Interesting. So instead of having this as a pattern, they kind of build it in. I wonder how that works. And then we have redirecting constructor, forwards calls to another constructor in the same class. Okay, so we have constructor that maybe has one less value, so it's gonna call the other constructor with providing a default value for something, right? You can make entire chains. So okay, I'm just surprised to see them kind of categorized in that way, because that's something that's usually just within a little bit more generic syntax. Okay, generative constructors. To instantiate a class, use a generative constructor. So there we go, with initializing formal parameters. So we just have, hey, this x and this y. So basically x is being defined in this position, y is in this second argument, and that's it. It's just gonna get initialized. So this is where those very simple cases where, we have this thing that holds values and bam, done. No biggie. You have default constructors. If you don't declare a constructor, Dart uses the default constructor. The default constructor is generative constructor without arguments or name. Great. And then we have named constructors. Use a named constructor to implement multiple constructors for a class or to provide extra clarity. Okay. So we can see that, hey, we have this one that sets x and y instance. So this is our normal generative one. And then we have a named one like point.origin, and here we have this fun syntax where x is whatever origin, which is 0, and y is 0, right? There you go. So that makes sense. Okay. A subclass doesn't inherit a superclass's named constructor. Ooh. To create a subclass with a named constructor defined in the superclass, implement the constructor in the subclass. I mean, it kind of makes sense, right? Because the superclass changes something. That's the whole point. It changes something. So we need to re-implement those. But why doesn't it apply to generative? I guess, I guess I understand, because with generative ones, we explicitly say that we set this value and set that value. And I guess in a situation where the subclass, I actually want to see that. So we have point 2D, okay? We have X and Y. And we specify our point, just point this X and this Y. Simple, right? We just don't do that. And wait, point 2D. Duh. And then we have additionally the point 2D, the 0, which will be the named one, right? And we specify that X is 0 and Y is 0. Okay, simple enough. So what if we do class point 3D extends point 2D, right? So I assume that both X and Y inherited, right? So we're just gonna add the double Z, which will be, again, a double, right? Now it's unhappy. Superclass point 2D doesn't have a 0 argument constructor. Try declaring a 0 argument constructor in point 2D, or declaring constructor in point 3D that explicitly invokes a constructor in point 2D. Oh, so okay, so this forces us to do that. Oh. Huh. So I know that I probably won't be able to call this one. So let's just implement the bare minimum that we need to do, which is point 3D.0, okay, which will be X, Y, and Z. All right. I mean, the implicitly invoked unnamed constructor from point 2D has required parameters. Try adding explicit super parameter with the required arguments. Huh? What? Okay, I don't know how to do that yet. And doesn't look like we're gonna learn it until we extend the class. Okay, but it's interesting. We'll need to return to that topic of let's see when which constructor is available, what we're forced to implement, what we're not. Interesting. A subclass doesn't inherit a superclass name constructor. Yeah, we'll read that. Okay, so then we'll just move on to the constant constructor. If your class produces unchanging objects, make these objects compile time constants. To make object compile time constants, define a constant constructor with all instance variables set as final. Okay, so basically, as long, I mean, this is static, so we don't care about that, right? We have the final, which is double. We have both X and Y. Because they're final, they won't ever change, therefore we can do constant constructor. There we go, immutable point, bam, and we know that we're gonna get something. While static, we have function, which is static, and const. origin, and that returns that object. Therefore, whenever we're going to reach out to the immutable point dot origin, we're gonna get exactly same object. It's not ever gonna get recreated. Lovely. I mean, this would be probably the same thing, right? Can we do something like that? So let's ignore this example. Let's say we have our immutable point, right? So what I'm gonna do is constant a is immutable point, let's say 3 and 4. Okay. And then we're going to create another one, which is b, with same input. Okay. Exactly same input. And print r equal. And this will be a is b. And in my opinion, it should be that they're equal. They are. Beautiful. So what if I'm going to make one as immutable object of 0, 0, and the other one will be immutable point dot origin. This is static constant. Oh yeah, that's just a constant. That's not even a function. So they should be still equal, right? Beautiful, they're equal. Therefore, we are not recreating a bunch of objects in memory. Okay, I like that. What if we're gonna call it without it? Let's say constant. Final C is immutable point 0, 0. Can we do that? Yes, we can. So are A and B equal? Then let's do A and C. And here we're gonna do B and C. And let's also do C and D. C and D. Wait, this doesn't look right. B and C. There we go. Whoops. So only A and B, only those two that are constants are true. Everything else is not equal because A and C, this is a constant, this is not constant, therefore new instance has been created. Same happens here, constant and not constant, and two instances are not equal either. So this means that, we could define something like this. It doesn't even need to be immutable point, whatever. We have just a point, right? Let's rename it all into point 2D, right? Something that you use everywhere. And by default, it's immutable because when you perform operations on it, you just create a new one. So not a big deal. Therefore, this is suddenly awesome because I can still have a function to compare them, right? So whatever. I know the distance or something, or maybe add, right? So let's do something that will return point 2D. And it will be add, right? And we just do point 2D, which is the other one, right? And we'll just do, we could probably do without return. We just use the fun arrow, and this will be the point 2D, where it's this dot x plus other dot x, and this dot y plus other dot y, right? So we can add, so we can still, no problem, do something like, oh, our, I know, x is a dot add b, right? We just added two of the same. Or we could do add c, right? or we could do C add with D. We can use them interchangeably. We always get a new one, right? Not a big deal. But that's it, right? The only not nice thing is that, afterwards we create new objects. So that's kind of not nice. It's not where suddenly like, oh, we're always getting a reference to something else because, everything's supposed to be a reference. So we can't super optimize it, but I'm fine. That's still nice. Yep, that is still nice. So constant constructors don't always create constants. They might be invoked as non-const context. To learn more about consult the section on using constructors. Okay, so now we have the redirecting constructors. A constructor might redirect to another constructor in the same class. A redirecting constructor has an empty body, and the constructor uses this instead of the class name after a colon. Okay, so we have the point, right? We have the main constructor and then point along x-axis, and we just do double x. So we do this, and then we call the constructor this and providing 0. Okay, that makes sense. It says it has empty body, so I guess we can define a body in a constructor. So let's just take a look at, this is simple, right? Nothing crazy. Sure. Factory constructors. When encountering one of following two cases of implementing a constructor, use the factory keyword. So case 1 will be the constructor doesn't always create a new instance of its class. Although a factory constructor can't return null, it might return an existing instance from a cache instead of creating a new one. Perfect. That's already kind of trying to answer what I was trying to say earlier. Or a new instance of a subtype. Look at that. You need to perform non-trivial work, or the other case is when you need to perform non-trivial work prior to constructing an instance. This could include checking arguments or doing any other processing that can't be handled in the initializer list. Tip: you can also handle late initialization of a final variable with the late final. Yep. So the following example includes two factory constructors. Logger. Factory constructor returns objects from a cache. Okay. Or logger from JSON. Excuse me. Factory constructor initialize a final variable from a JSON object. Okay, so this is basically a constructor with a body. That's it. They called it factory. Really? So we have the logger, right? We have final string name and a boolean if it's mute, so that one can change. So underscore cache is library private thanks to the underscore in front of its name, right? So we have static, okay, so shared between all the instances. Therefore, our constructor should be able to access it. And then we have final map string. So maps from a string to a logger. Okay, and this will be our cache. We just create new empty map. Lovely. Why do we need that if we already have this defined? Okay, factory logger, string name. So this will, we're straight up use factory. Wow. So this is like separate keyword for that. I did not expect that. So we have our logger string name. So we give it a string name, and this will be basically return cache put of absent. There we go. And boom. So put if absent is a built into a map where we just have this caching method. I like that. That's nice. This is handy. So yeah, otherwise just, create a new one and bam. And we call that underscore internal. What the hell? logger.internal. Oh, so you can make a named constructor with where the name is underscored, therefore it's library specific. Ooh, like kind of equivalent of a private. Interesting. Although I would still like the private keyword. All right. Okay. So that was this one. So we have a normal body where we return stuff. Okay. And we still need to call a constructor nonetheless. Okay. I don't like that because that means that we always have to have those. And then we have factory logger from JSON, right? We just pass a JSON, whatever, JSON name to string. Okay, we just extract the name, right, from the JSON, and we create a new instance of a logger. So we call the logger with a name, which is this factory. Okay, so we're using this factory constructor from within this factory constructor, and that's it. Okay, simple enough. But why do we deal with this random factory keyword? I don't understand. I want my normal constructor where I can have whatever logger dot something this and put my, the body in there. Warning, factory constructors can't access this. Okay, all right. Use a factory constructor as any other constructor. So we just call it logger dot from JSON. So from usage perspective, it's great, but from creation, it's they have redirecting factory constructors. So a redirecting factory constructor specifies a call to a constructor of another class to use whenever someone makes a call to the redirecting constructor. Specifies a call to a constructor of another class to use whenever someone makes a call to what? Factory listenable.merge. Okay, so a constructor named merge. And it's a factory constructor. We give it a list of listenables. And we just say it is this constructor, right? And that's it. It's just an internal one. Okay, great. It might appear that ordinary factory constructors could create and return instances of other classes. This would make redirecting factories unnecessary. Redirecting factories have several advantages. An abstract class might provide a constant constructor that uses the constant constructor of another class. Okay, this is starting to get weird. An abstract class. Okay, we have an abstract class. Might provide a constant constructor. Okay. So first of all, an abstract class has a constructor, right? That's already weird. That uses the constant constructor of another class. Okay, that's weird. Redirecting factory constructor avoids the need for forwarders to repeat the formal parameters and their default values. Yeah, exactly. So instead of doing, we need to call this and pass in this argument, possibly more, we just do this and that's it. It's just at that point, it's like, what's the point of this part? Don't know. Weird. I guess because we want to slap on a name and that's it. Instead of exposing like a default one. I don't know. Strange. And then we're going to complicate it with tariffs. Oh dear, I'm barely a third through this topic. Holy moly. That allows you to supply a constructor as a parameter without calling it, called a tariff, as you tariff the parentheses. Okay. Serves as a closure that invokes the constructor with the same parameters. If a tariff is a constructor with the same signature and return type as the method accepts, you can use the tariff as a parameter for a variable. Okay, so we can kind of use it as a normal function. Tariffs differ from lambdas or anonymous functions. Lambdas serve as a wrapper for the constructor, whereas a tariff is the constructor. Okay, so use tariffs, right? The good approach will be like, hey, strings is we have a list of character codes and we map them and we just provide string dot from character code that would take in the character code and bam, we just call the constructor. Okay, that's intuitive. Or use a tariff for an unnamed constructor, right? So, so we can't just provide string buffer, right? We actually, because I guess it's not aware that we're providing a constructor instead of a value, right? So we need to do dot new. I don't like that because suddenly it looks different than any other code, but okay. All right. I'll live with that. And wrapping in the lambdas is just, repeating yourself, so why bother? For more discussion, watch this decoding Flutter video on tariffs. Okay, there we go. And there's a tariff and it kinda looks obnoxious. It's weird how Google provides documentation for the videos. I don't like that. I'd prefer to read it. All right. Even if in the form of a tutorial, like a blog post or something, instead of a video. Instance variable initialization. Okay, Dart can initialize variables in 3 ways. Initialize instance variables in the declaration, right? We just provide, initialize the instance variables when you declare the variables, right? There we go. The implicit default constructor sets these variables to 1 and 2. Yep. Use, oh wait, what is this? Override. Oh, this is just overriding the existing thing to just print it nicely. No big deal. Use initializing formal parameters. Use initializing formal parameters. Simplify the common pattern of assigning a constructor argument to an instance variable Dart has initializing formal parameters. In the constructor declaration, include this and the property name, and omit the body. The this keyword refers to the current instance. When the name conflicts, when the name conflict exists, use this. Otherwise, Dart style omits the this. An exception exists for the generative constructors where you must prefix the initialization formal parameter name with this. As noted earlier in this guide, certain constructors and certain parts of constructors can't access this. These include factory constructors. Yeah, they can use this. The right-hand size of an initializer list. Okay. Arguments to a superclass constructor. Okay. All right. Within the arguments to the superclass. Okay. Initializing formal parameters also allow you to initialize non-nullable or final instances variables. Both of these types of variables require initialization or default value. So we have final x, final y, right? We have this one, sets x and y instance variables before the constructor body runs. There is no constructor body. Initializing formal parameters can also be optional. So point B dot optional. So we have, okay, optional parameter 1, optional parameter 2. That's interesting. This x is 0 and this y is 0. Okay. So it turns out we can't add those values. We just need to follow those rules for those funny little optional things. I did not expect a syntax like that, but I guess I should have. Okay. So now private fields can't be used as named initializing formals. So class point B, so named private require double x, double y, and this is x, and this is, so we have some private fields behind the scenes, and we're trying. Oh, so they're saying that this, after this, is the body, and therefore we can say that these are the arguments, and this will try to set x and set y before we run this. Therefore, the private ones could be used, but private fields can't be used as named initializing form. Oh, as in we can't provide them here. We have to do it here. Okay. All right. And this also works with named variables. So this must be set constructor. This must be set. So point C named, and we can just do the named ones. Okay. All right. So we would need to specify x and y. Huh. That's an interesting one. Okay, this shows a lot more tools suddenly to make those constructors, but at the same time it just becomes so complicated. Like, oh, there's 30 ways to call this constructor. What's the idiomatic way then? All variables introduced from initializing formal parameters are both final and only in scope of the initialized variables. So to perform logic that you can't express in the initializer list, create a factory constructor or static method with that logic. Oh, you can then pass the computed values to a normal constructor. So the constructor parameters should be set as nullable and not be initialized. So what is or static method with that logic? You can then pass the computed values to a normal constructor. I need to try something. So we have this point, right? What if I always want to double the y? What if I'm gonna say this x and we're gonna say y is x? I can do that. Can I do y is 2 times x? I can. Huh. Or we define a static function that we pass something to. Sure. But okay, we can do some basic calculations here. That's okay. All right. I can live with that. I was kind of expecting that I would be able to do maybe something like, oh, so you know what? We have the double x that we can provide, and you know what? We're gonna say that this dot x is x, right? And this dot y is 2 times x. And maybe do some calculation here, right? I would like that. But now, instead of that, one needs to have a separate constructor and then separate factory. So I would need to basically have constructor point to D, right? Where I have this dot x and this dot y. And that's it. And then I can do the whole factory point to D, which takes and x and y. And suddenly this collides with this one, I guess. So I would say final real y is 2 times x, right? Or maybe do more here. And then, how was it with the factory ones? That's the redirecting constant named. Where's the factory? Here. We just return something like we call, oh, okay, so we literally just return. So return point to D with X and real Y. But now it's unhappy. So I would need to do underscore internal. And therefore I can do this. Int. Oh, sorry. Double. Right? Now it works when I hit this one. But what I don't like about it is that if I have 30, maybe 40 variables here, I need to have them all as a list here and all as another differently formatted list here. Lots of typing for no point. Boilerplate, boilerplate. I like a lot of solutions here, but not this one. Okay, so we did that. Use initializer list. Wait, what are we doing? So we did this one with name variables. Yep. And are both final and only. To perform logic, we just use factory or static method. And the constructor parameters could be set as nullable and not be initialized. Okay, just, allow for non-initializing. Yeah, whatever. So this is with formalizing, or you could just call it without, because the default one can be formed for that with everything being null. Okay. Oh no, because this one will override the. Yeah, so this one, because this one's defined and not named, I guess it overrides the default one. So if I'm gonna grab this point D, just random point D, right? Ignore that. Const A is point D with this and this. Double and double. What does it complain about? The constructor being called isn't a constant. Oh, duh. Okay. So that works. This worked, no problem. But that means I can also do this, right? Which kind of sucks. And that means I can't do this. Yeah, I can't use the default one because I just overrode it. Don't like that. Okay, use an initializer list. Before the constructor body runs, you can initialize instance variables. Separate initializers with commas. You can initialize instance variables. Initializer list sets instance variables before the constructor body runs. So we have point from JSON. So this is a normal constructor. We just give it a map, right? And what? And then X is JSON that, Y is this from JSON, right? And then we have a body that just prints something. The right hand side of an initializer list can't access this. Which one here is the initializer list? We have never seen a syntax like this. And this doesn't look like initializer list. This kind of looks like an initializer list. What the heck? Um, I am confused. Let's just do this. Let's actually keep the uh let's actually keep the little override of a string there. Let's get rid of our point to D. We don't need it. It just confuses us. So we have this thing, right? And therefore, do we have a way to call it? Point with assert this, assert that, and just print. Oh wow, so that's separate. So let's just do final A will be point where we need to specify the JSON, right? So test what X is this and Y is this. And what the hell's going on? Doesn't have an unnamed constructor from JSON. So what is going to happen now? Endpoint from JSON. Okay, we have 12.3, 41, 2. So it looks like this run first because we extracted those, and then this thing run. So it looks like we initialize the actual value here. We initialize the actual value here. Can we change it here? Can I do y is minus 100, 1000? Looks like I modified its values. Okay, it printed that here, but did it actually save it here? This is so confusing. So after that, we're gonna just do print after constructor will be A. Okay, so we actually saved this. We actually saved the value. What if I can't create a new variable here? Could I straight up remove that? Oh, wow, look at that. This just works. What was I doing before that I just didn't have something? Can I do this? I can save it and should complain that X is not set. Is null. What if I'm gonna make them not null? Now it's complaining. X is minus 2. Now it's complaining. Non-nullable instance field X must be initialized. Try adding initialized expression. Okay, so that's the problem. We can't just do this. And set X is 0 and Y is 0. And then we can update them. But if we'll make them final, probably won't work because right now it works, right? Oh, we actually set the value. Great. But if I'm gonna make it final, then this won't work because we just set those. Therefore, we can't do calculations here. So yeah, this sucks. This officially sucks. Warning, the right-hand side of an initializer list can't access this. So this can't access this. And I thought this didn't access that either. So to validate inputs during development, use assert in the initializer list. So we can just add assert here randomly. I guess that's some kind of special case. This is very weird syntax. Like you can throw in random pieces of stuff, and then you can just print it afterwards for who knows why. Or I mean, you could update something else that hey, this thing was created, although I don't have reference to this. Initializer list. I mean, in C#, it was a common thing for me to create a constructor that actually registers itself, like the object that just created, to let's say to the static list or something for caching, for example, right? Because if I have this, right, okay, I initialize both. It doesn't seem like I can just print this, right? Oh, I can. Look at that. Looks like I potentially could. All right. Okay, this is a little bit better. Because that means that in theory, I could have static, let's do final static list of point. Okay. Which will be instances. Okay. And this will be just list of, I mean, I can just do this, right? The modifier static should be before the modifier final. Okay, great, whatever. Static final. That means that whenever we create an instance, let me just get this proper initialization here, the first thing, or like the whole thing. So we just have this, right? So instead of this random printing that doesn't do anything useful, we'll just do instances dot add this. And somehow from the constructor, I can instantly access static stuff. Okay. So I could just do this, right? After constructor, and we'll do point dot instances map, and we're just gonna do print, right? We're gonna print all the instances. So at the end, we'll just get one thing, right? Or nothing. Oh no. Why? I created it here. I'll create more. B and C. And do this. After constructor. And we have the points. So looks like, why does it print it only once after constructor? So it totally ignores that. Why? Instances add. Adds value to the end of this list, extending the length by 1. Is this empty or something? This is of type point, right? So this should be updated every time I call from JSON. Something wrong with our print. So at the end, let's just do print point instances. Okay, and we'll also print, we have something like length. Instances printed this. So we have them. Why can't we iterate over them? Oh, because we mapped. No, map and print. We passed them to print. So this should have worked. Oh, no. For each, I guess. Because map doesn't, yeah. Silly me. Yeah, map doesn't really execute stuff. Okay, there we go. So that works. Okay, we can do some stuff. The moment we can access the completed this after the fact, it's a little bit better. It's just too bad we can't do some more complex calculations beforehand without creating a separate static function just for this purpose. Yeah. Complicates things, but not a big deal. The right-hand side of the initializer list can't access this. Yeah. To validate inputs during development, use assert and initialize a list. Lists help set up final fields. The following example initializes 3 final fields in an initializer list. To execute the code, click run. So we have this, we have double x, y, and distance from origin is this. So they call this initializer list. Okay, great. Well, I guess whatever is in brackets is called body, but it's like they don't mention anything about how to define the body. What the heck? Constructor inheritance. Subclasses or child classes don't inherit constructors from their superclass or immediate parent class. If a class doesn't declare a constructor, it can only use the default constructor. A class can inherit the parameters of a superclass. These are called superparameters. Constructors work in a somewhat similar way to how we call a chain of static methods. Each subclass can call its superclass's constructor to initialize an instance, like a subclass can call a superclass's static method. This process doesn't inherit constructor bodies or signatures. Okay, so non-default superclass constructors. Dart executes constructors in the following order. First is initializer list. Okay. Second is superclasses unnamed no argument constructors. Okay. And then we have main class no argument constructor. Okay. If the superclass lacks an unnamed no argument constructor, call one of the constructors in the superclass. Before the constructor body, if any, specify the superclass constructor after calling. In the following example, the employee class constructor calls the name constructor for its superclass person. To execute the following code, click run. So we have the person with some first name and a name constructor. Okay, it just takes a map of data and just prints a in person, whatever. Oh, so it leaves this as null, right? Because it doesn't specify any actual thing to save like this. And therefore, yeah. Okay. So then we have class employee that extends a person. Person does not have a default constructor. You must call super from JSON. So employee from JSON, right, is super dot from JSON data. Can you mix this with some additional values like X is this and whatnot? I guess so. We'll learn over time. I guess we'll learn a lot on what are the good patterns to use it once we start actual coding of something practical when we use some other external libraries and learn a bit. So we'll see. As Dart evaluates the arguments to the superclass constructor before invoking the constructor, an argument can be an expression like a function call. Okay, so this person's, and then we have constructor employee, which does super from JSON, and we can do some additional stuff here. But I presume that function call needs to call to a static function or top level function. Arguments to the superclass constructor can't access this. For example, arguments can call static methods, but not instance methods. Of course, yeah, because we don't have, the object hasn't been created yet. Superparameters. To avoid passing each parameter into the super invocation of a constructor, use super initializer parameters to forward parameters to the specified or default superclass constructor. You can't use this feature with redirecting constructors. Super initializer parameters have syntax and semantics like initializing formal parameters. Version note, you need to use very old stuff to not have it. Okay. If the super constructor invocation includes positional arguments, super initializer parameters can't be positional. Okay. So class vector to D, bam, and has simple little generative constructor. And then we have vector 3D, exactly, which extends it with Z. Okay, since instead of doing this X, this Y, and this Z, we do super X to set the super X as a first parameter, super Y, and this Z. Okay, that makes sense. So it's better than final double X, final double Y. Oh, that's how we do it. So it's just a variable. It's just a variable. Automatically sets our local. And then after this happens, I guess, or like before this gets all calculated, we call this and then throw it out on top. Okay, makes sense. To further illustrate, consider the following example. If you invoke the super constructor super0 with any positional arguments using a super parameter super x, results in an error. So if we're gonna do x vector 3D x-axis error, so we just add another constructor with super x, and then we specify, hey, z is 0 and super is 0. It's bad. How would we call? Oh, what? If you invoke the super constructor super0 with any positional arguments using a super parameter x, results in an error. Okay, because we are trying to use super here and here. Okay. A bit confused. What's the big deal? This just doesn't make any sense. This name constructor tried to set the x value twice, one in the super constructor and once in positional. And select store, bro, whom you're teaching to? Myself. I'm reading documentation for myself, and if somebody wants to hop in and join along, go ahead. I'm learning Dart. That's all this. Just like the title says. Couldn't be simpler. No, I just found that, being a live stream forces me kind of to stay on topic for whatever, 3-4 hours. So I don't get distracted because, hey, somebody might be watching. This is getting recorded and it's going to stay on a channel. And the other thing is that, as I'm reading things, I'm trying to explain them. And that means that I need to actually try to understand some of the topics. Because without that, I often catch myself just skimming. And the moment you start skimming through documentation, you actually didn't get like 90% of it. That's what I learned so far after, I don't know, 50 episodes of reading various documentations. Crazy. Alrighty. And Slexor says, okay, I got it, bro. You're doing great. Thank you. So what the hell was this saying? Oh, so yeah, so this tries to set the x value twice, once in a super constructor and once as a positional super parameter. As both address the x positional parameter, this results in an error. Exactly. It's obvious it doesn't make any sense. When the super constructor has named arguments, you can split them up between named super parameters, like super.y in the next example, and named arguments to the super constructor invocation. Okay, they're going a little bit over the board here because this is starting to get really complicated. I mean, it's not complicated, it's just like you bothered to implement all those crazy features, yet you didn't some of the most crucial ones. What the hell? Alrighty, class vector 2D. Vector D named. Require this X and require this Y. And these are named, okay? And because they're named, we need to throw in the required, otherwise I don't know. I mean, they don't have default values, so I'm confused. Alright, so then we have class vector 3D extends it, okay? So we have vector 3, YZ plane, right? So we provide those named ones. Y, okay? And Z, notice that we skipped X. And then we provided X is supposed to be 0. Okay, so that makes sense. It's just we can't really do it in a nice non-named way. Let me borrow this example because I want to try something. Can I kind of do it halfway with positional ones? Let's get rid of the point. We're past that point, right? So we have the 2D, which has just normal positional ones. Then we have 3D. Chris says, hi. Hey, how are you? Okay, so let's say that we have our vector 3D, right? Normally it was calling super X, super Y, and this Z. But what if I want to do super and something like X and Y? And I'll just make them simply, what was it? Double X and double Y. Okay, this isn't unhappy. This actually might work. So I still have them positional, right? Or maybe I would want to do something like this, and then this one will be 0. Okay, so I can do that. It looks like you can just take this, maybe this times 2, right? Not a big deal. Or maybe we wanted to get back to this part where we do just super dot x. Oh no, but that means that I won't be able to use this one anymore. Yeah, so we need to kind of, the moment we want to do stuff manually, we need to do manually, and therefore I can just do this times even that, right? And do some calculations here. Okay, all right. I'm starting to get some of the stuff. Chris says, just asking, why would someone learn Dart instead of using Flutterflow? Don't know what Flutterflow is. I'm learning Dart as a language itself. Flutterflow sounds like one would do graphical programming, like nodes. I'm looking at Dart not from the perspective of Flutter. Right now, I don't have intention of using Flutter. I'm just looking at Dart from the perspective of either CLI, like terminal apps, or actually writing a simple backend servers. Yep. I know, it's shocking. Who would think about Dart other than for something like a CLI command line interface? Like tools. Whatever. I don't know what to write. BTOP, right? Here's your CLI. I mean, this is like TUI, terminal UI. But yeah, anything, any stuff. Actually, if you want an example of a good CLI app, you can go to, what is it? The GitHub Stacks Terrace. There you go. This is actually written in Dart. You have straight up, using like Stacks help and all that stuff to manage your Git stuff. And then on top of that, you actually have, like Flutter UI and a bunch of other stuff. I'm gonna throw in a link if I'll figure out how to get to the link in this funny little browser. There you go. If you want to check it out. Alrighty, going back to the documentation. To further illustrate, Krish says thank you. You're welcome. So yeah, we went through that, no big deal. When the superconstructor has named arguments, you can split them. Okay, we went through that. All right, so we're past constructors. Oh, wow. Awesome. And what time is it? Wow, it's nearly 2. Okay. So yeah, I guess I'll be finishing for tonight because this is going slowly. We'll learn about yeah. But going through normal functions and then through these basics of classes, I think there's just too much about constructors. Way too much about constructors. They're just overcomplicated the whole thing. Other than that, overall classes, like, it's fun. I like the implicit interfaces. So it looks like there's somehow tons about constructors, very little about methods. There will be very little about extending a class. And then a little about mixins, which might be actually fun. Enums, I guess they're considered classes. And then I'm really waiting for extension methods, how they solve that. There's a little bit about it. We have keyword extension. On what class? Okay, already can do that. But yeah, extension methods are great. Extension types, there's tons of that on that, but I recall that this was like kind of lame. And callable objects, which is just weird concept, but it exists. So yeah, definitely on next stream we'll be finished with classes. We will skip the modifiers for now because I don't expect that it will be building a big project yet. Maybe we'll just take a peek whenever we need to. But I would just want to go over just overview of concurrency, which should give us an idea of how to do it, because unless we're making some very simple app, we'll be dealing with asynchronous stuff. And therefore, it will be nice to understand how it actually happens. Oh, we have an event loop. That's great. We have some other stuff. How to deal with it, and roughly asynchronous programming. I already saw that, okay, we just have a concept of a future and a wait. So in theory, I would be able to use it. But I want to know, how it works when it comes to maybe server side. Does it spin up separate threads or something? Or is it more like JavaScript where it pretends that it's, doing something? And I guess, I recall the isolates were like the actual separate threads, while asynchronous programming is more like JavaScript. So I don't know, maybe we'll look at that, but I would like to start building a little project, and I think I'm gonna combine it with my other, what's called a series of streams. There was only one, where I'm learning React like from scratch. So in that React live stream, I was mentioning that I want to build maybe a, like, let's call it simple habit tracking app. And I was thinking like, I could reach out directly to the database and whatnot, but that would probably overcomplicate the whole thing from the perspective of the first React app. So maybe I will just make it where we are going to write a simple backend in Dart and front end in React and see how that works. And for that, on the Dart side, we would connect probably to SerialDB, because how do you search Dart packages, libraries? Do we have something like that? The official repository. SerialDB. There we go. We got SerialDB Dart, and second one and third one, holy moly, Query Builder. Okay. Wow, I did not expect so much SerialDB stuff here. But yeah, there we go. We can just use simple library. Doesn't look complicated. see how that goes. This should force us to learn how to deal with, actual objects, unwrapping them, doing some basic async stuff, maybe how to structure so that we have configuration in a different file, and a few of those basic things. And on top of that, just throw in a simple web server. We don't need to worry about super security. For now, it's just a simple thing. So we'll just make it, very, very, very simple. And simple React frontend and see what happens, right? So that could be a fun little project. So I don't know if I'm gonna have like a separate Dart and separate React streams. I think they could be combined. I just know that with React, I need at least one more live stream to read through the documentation. And after that, I could probably start combining them too. We'll see when. I'm starting to consider streaming like during the day for a change, and maybe like actually switch to every day or something. I don't know. But yeah, probably after this weekend, I'll know how to proceed, and yeah, we'll see. For now, I'm ending. It was actually kind of fun to read through the stuff. I'm looking forward to finishing classes. So yeah, thank you for watching, and yeah, see you next time.